Good morning. Today is Saturday, January 11th, 2014, and our special speaker today is Ed Dowdey. Last week we had our special town hall meeting relating to the issues with the NPA board and uh, and what's going on with the situation between Jim Newbern, Barry Springer on one side and Dave DeHilster on the other. And we don't want to spend a lot of time dwelling on that today. We're probably going to put out a new petition, just articulating exactly what our expectations are from Barry and Jim. And because they have not, as of this moment, have not stepped down, we don't see that as a big deal, frankly, because we're just going to go on and do what just do science and in fact, David has some really good ideas for doing some stuff that I think the members are really going to like. So that's good news. We're just going to go on and do science like we've always done, and move forward. We're going to have the Saturday morning sessions. Somebody's echoing here, and we can talk a little bit about that after Ed finishes his talk today. So let's not take any more time with that right now and just get right on to the business of doing science. So Ed Dowdey has been involved obviously with the NPA for, I don't know, about 5 years. I introduced him to it. I think his first conference was the Stores Conference in 2009.
Right.
And but he's been involved in this a lot longer than that. He wrote a book on the extinction shift principle, and I want to say that's 10 to 15 years old now. And has had some really innovative and original ideas relating to Einsteinian relativity, mostly what's wrong with it, and about light bending and how it doesn't happen in a gravitational field and what the consequences of that might be. Some pretty foundational and profound stuff. He's going to be This will be a repeat of some of the material he's given in the past, but also some new insights in that. So today he's going to be talking about gravitational deflection, or I should say the lack of it. And I'll let Ed get into more details on that. And so here we go. Ed Dowdey, take it away.
Yeah, and good morning to you, Greg, and
Oh, one last order of business.
Pano and Hans. Yeah, and I
Let me
hope
just
you
take
guys can
one
hear me
quick
well.
order of business. Those of you that keep yourselves muted if you're not speaking, but also keep your cameras off if there's no reason for us to look at you. So I'm going to turn mine off. And Pal and
I was
Hans, if
enjoying
you
looking at those guys, man.
oh, there's no reason to. Well, I just need to see you right now.
Yeah.
So that's just kind of our custom. Obviously, do turn your camera on when you're speaking. So that's it. Sorry, Ed. Thanks.
All right, very good. All right. What we'll do, I'll go over some fundamental research that I have been doing over the years, and primarily looking at two areas in our universe, and that is our sun, and also at what is known as Sagittarius A at the center of our galaxy. So I'll just focus on what is known as the gravitational deflection or gravitational light bending at the sun. And as you know, this is about a little more than a century old now, and it's been going on for over 100 years. And since Albert Einstein came up and tried to explain what he thought was going on at the sun, and correctly, as the relativity has pointed out, that at the surface of the sun, or at the just above the surface of the sun, we have a plasma limb. There is bending taking place there. And what I have done, I've looked at that, what is known as the gravitational deflection at the sun. And what I have determined, there is actually a violation, right? According to general relativity. I'm looking at the observational evidence. And I, I focus on the observational evidence and the fundamentals, right, of general relativity. I'm not mentioning anything about my theory and what I have done. My theory had given me the tip off and the the idea that there's something wrong with general relativity. And in Euclidean space geometry, you can predict certain things that's going to happen. And if you don't use relativity, then you avoid the so-called solar light bending effect, you avoid time dilation, you avoid the warp space and the different geometries that relativity uses. They leave Euclidean space and go into what is called uh, a Riemann space geometry or warp space geometry, using Lorentz contractions and time dilation and the fundamentals of deviating from the Euclidean space and the bent space, what is called a space-time effect. If general relativity were correct, and what Einstein predicts happens is that the gravitation actually affects light. Gravitation actually bends light, and what happens is if you look at this image that I have here, you see the surface of the sun. And can you see my pointer?
How we're going to do it?
Is my pointer present? Let me see.
Okay.
I don't.
Well,
I don't know if I'm using the
we'll give
pointer
you a
correctly.
call probably within 10 minutes. How's that? Yeah.
Let me
Okay.
see.
Sounds
Okay. Well, I'll just. Is it a pointer? I thought there was a pointer here someplace. Am I doing this correctly?
Okay. Ed, can you hear me?
Yes.
Yeah, there's a pointer at the top. It's a little like a line with a little red tip on top. If you hover over it, it says I point.
Oh, I point. Here it is. Yes. Yes. Yes.
There
Okay.
you go. That's your
I'll
pointer.
take that. I drag it down. Oh, here we go. Now, there we go. Now I have my pointer. Okay. Can we see that? Am I okay now?
We see it.
Yes, we see
Okay.
it. Every time you say that, I have to unmute. So
Okay.
uh,
Okay. Good.
I'm
All right.
muting, so it takes me a while to unmute. Sorry about that.
Okay. Good. Good. I just want to make sure I'm using the pointer correctly. And what takes place at the surface of the sun, that you have a plasma atmosphere of the sun, and it's about five to 6,000 degrees Celsius plasma, where you have an atmosphere of almost full of ionized particles, right? And these are positive, negative charges that are in the gravitational grip of the sun. And you think of the fact that if it were not for the gravitational field of the sun, as strong as it is, this plasma would not exist in this thin film, right? And you can calculate or assume that if you have a light ray coming from a distant light source approaching the sun and propagated through this plasma, the plasma is affected by the solar gravitational gradient field. And if this plasma has a gradient acting on it, like the gravitational gradient of the sun, almost surely you can think that this light will have to be bent by the plasma, and the light is interacting with the plasma only and not the gravitational field. And so that's what I started to look at in my principles, and I looked at that in depth because the fact that if relativity, according to general relativity, this bending would take place here at the surface of the sun, where relativity has made relativity famous, and this bending, you find out that being observed for the past 100 years, here's a bending effect that's 1.76 arc seconds, right? 1.76 arc seconds from deviating from the straight line path coming from the most distant source. If I take a dotted line and go straight where there's no bending at all, and the difference between that and the bent light ray, this angle is 1.76 arc seconds. And the equation here, given that is 4 times the gravitational constant times the mass of the sun, and the total mass enclosed in this sphere is m, which is the mass of the sun, divided that by the radius of this Gaussian sphere, and divide that by c squared. This will give you an angular deflection in the units of radiance, right? And radiance is a natural angle, given the fact that you're using kilograms and you're using meters and meters per second square and the gravitational constant in the MKS system. So this whole bending effect is in the units of radians, right? So that being converted to arc seconds, it's just a matter of using the geometry, the fact you have 360 degrees is 2 pi radians, right? And they're taking 360 degrees and 2 pi radians, and each degree has a minute, and each minute has an arc second. Then this would be 1.75 arc seconds, right? So let's go forward and I'll take that and show what the fundamentals are. And one thing that people cannot argue with, and I say this all the time in my presentation, that now we go outside and we can have a battle about something. You step outside, right? You take 10 paces, turn around, you settle the argument, and the guy pulls his gun out and turns around and fires, right? And then the argument is settled. But to settle an argument in science, how do you do that? First of all, there are some fundamentals that we cannot argue about. And one of the things that I would not argue with people about, and that is the fundamentals, right? So we are supposed to be using the fundamentals. When we go to, I do my work here in the USA, somebody else does their work over in China, or India, or Germany, or wherever. We should be able to use the same fundamentals. And if we take the same experiment, we ought to come up with the same result. So if relativity predicts all these things will happen, and we look out into the deep space, and you see some events going on out there, you apply the fundamentals to it, you ought to be able to come up with an explanation. So explaining that using these fundamentals, I use, first of all, what is known as Gauss' law. So if you take Gauss' law, for an example, if I have any mass, no matter what these masses happen to be, if this mass is M, and all the mass M is enclosed within what is known as a Gaussian sphere, and the Gauss sphere has a radius of R, then that mass enclosed in that Gauss sphere, if relativity says, I got a star out here somewhere, and I placed the star here, and there's a light ray coming from that star, going past this mass, right, and going to the observer, the total bending should be what happens if there's no bending at all. The star would be here, and it would be a straight line coming past. If there's no bending at all, it would be a straight line. This light would be a straight line. But that's not the case. It has been demonstrated, even using general relativity for the past 100 years. If there's a star out there in deep space someplace, and we are the observer with a telescope over here, what we notice is the star is actually located somewhere behind the rim of the sun. And we are the observer over here, we notice there's a light bending coming to and fro. So there's light bending coming approach, and there's a light bending receding. We take that same mass, and if we would compress that mass or make a smaller mass that's more dense than the previous mass, if it's more dense, then taking a Gaussian sphere, the same radius, right, we should get the same bending, no matter what. So Gauss' law says is the gravitational flux at the surface of a Gaussian sphere, or an analytical Gaussian sphere, is a function of the mass that is enclosed within the sphere. We use that for gravitation, and we use the same fundamental for electromagnetism. And you've done charges where you had physics in academia, where they teach you using Gauss' law. You have the mass, the charge enclosed in a Gaussian sphere determines how much flux of the electrostatic flux is at the surface of the sphere. This uses the gravitational equivalent of that, saying the gravitational flux at the surface of a Gaussian sphere is a function of the mass of the enclosed. So if these two masses are the same, and if I take this mass and compress it down even further, and I have something approaching something like a dwarf star or something like a theoretical black hole or whatever it happens to be, a supermassive object, and theoretically you can compress the mass of the Earth down to something probably not much bigger than a golf ball, right? And that that golf ball was supermassive object of the Earth placed inside of a Gaussian sphere that has the radius of the Earth, right? The gravitational field at the surface of this Gaussian sphere should be the same as the gravitational field at the surface of the Earth, or 9.8 meters per second square for gravitational acceleration, or 980 centimeters per second square for an acceleration of a Gaussian sphere. If I take a compressed mass or some supermassive object that had the same mass of the Earth at this center. So going forward, that's Gauss' law, right? So Gaussian law should be no argument about this whatsoever. And also another principle that is called the principle of reciprocity. If we take any physical problem, a physics science problem, a telescope, or some kind of optical device out there, and you have a light ray, right, that's projecting in one direction, and if I take that light ray and turn it around and send it back in the opposite direction, the principle of optical reciprocity says that you design a telescope and you got a light ray coming through a telescope, and it does some things fundamentally inside the telescope and comes out to the other end. Then what happens if you take that ray and send it back the other direction, it should take exactly the same path. So we use that to design telescopes, we design microscopes, we design even electron microscopes, whatever. The principle of optical reciprocity allows you to help you design instruments or design optics or satellites. We use that all the time. So relativity should, if it is a valid principle, should abide by these principles also. So that's the principle of optical reciprocity. So going forward, taking all these three and put them together again, what we just talked about, you have the principle of Gauss' law and the principle of reciprocity. Taking all three of those and come together again, you should have the light bending should abide by all three of those. So I show this all the time where you have if a star, according to the cosmology and people who study the stars and the formation of stars and the stars that are short-lived, and the star burns out, completes all of its energy and burns out, that star will collapse down to something like a dwarf star or some star like some collapsed supermassive star or even a neutron star if everything burns out completely. So there are a number of objects out in deep space that are causing some problems where you know it's there, but you see the effects of it because of gravitational tug is pulling on things, right? So this is what happens. You have objects out in deep space that don't emit any light whatsoever. There's no emission coming from it, and it's completely dark, but you see the effects of it because of the gravitational effect. So that's summarizing what I just said. And optical reciprocity using Gauss' law and the fundamentals that we have here. So these are the two principles put together again, and summarizing what we just stated, and those pictures in the past. So now let's put this in play. If I were to actually exercise what we just talked about and looking into deep space, if relativity were the Bible that describes what goes on in deep space, no matter whether you're talking about stars or black holes or galaxies or whatever, then these principles should be adhered to. So any light ray coming from a star approaching some lens, and that lens being some mass where this X is, if that mass were prevalent enough mass there, that mass should have, according to general relativity, an effect on all these light rays. So let's place a light source here on the right and an observer here on the left. And if you put the lens halfway between the star on the right and left, and a line joining the source and the observer, and we place the lens sitting on that invisible line, then one of these rays would be responsible for generating what this observer sees as an Einstein ring. According to general relativity in the theory of light bending, the observer should see an Einstein ring. Here, this is in the textbook. And most textbooks will show you that you have a light source. If it's a red emitting source emitting red light rays, then the observer should see not a point. He wouldn't see a point source. He should see, because of this lens here in the middle, he should see, looking in his telescope, he should see what is known as an Einstein ring. So let me get my pointer here again. I lost my pointer just a second. So he should see, because of this source, he should see what is known as an Einstein ring. He would see, if without this bending whatsoever, he should ordinarily see a point, a light source in the middle, like a red star. But he doesn't see that according to general relativity. He should see an Einstein ring, because inside of that Einstein ring, it should completely dark void in the middle. There should be no light at all in the center of this thing at all. Because the reason why you don't see the light at all, and according to theoretically what they're looking for in deep space, they're looking for things like this that has a black spot in the middle where you see no light at all. The reason why you don't see any light at all is what happens in his telescope. He sees light energy because of this light ray coming this direction. If you extend that light ray coming back in the opposite direction, going all the way out here in the deep space, he should see, he would think this source is not here, but located right there by extending his telescope. He thinks he's looking over here, right, in this place. But down here, he thinks he's looking over here. So he should see a ring going around like this. He should see that ring, right, and not this point source. So placing this telescope where it is, he sees this angle, right, an angle between the line joining the source and the observer, and he sees the light ray going extended out, right? So therefore, the diameter of this ring is a function of the distance of the observer from the lens to the source, right? So if I place here as a test some other source, let's say a blue light source or a green light source, place it right there, right? And if I had some kind of spacecraft that can fly out here in space and place that source here. So he should see also, it's the principle of optical reciprocity states that the light coming from this source and placed on, sitting on top of this light ray, he sends out, say blue light pulses, right? And that pulse should take exactly the same path coming from that source to the observer, right? And that's the principle of optics, right? That states what should happen. And if this is the case, then what the observer should see, he should see the image of this point light source sitting right on top of the Einstein ring. And he should also see the image of this distant source, which is the red source, in the form of a ring. But here, this source, the light rays coming from that part of this source here will travel along this light ray, right? But he shouldn't see any green light coming from this way at all. Right? The only green light you should see coming from this area will be on top of the ring as he looked at in his telescope, right? But however, if this ring, if you move this source out further, right, he may see, not only can moving the source even closer to him and coming down, he may see this light source coming in near field, right? And the near field observer should see this source instead of it sitting on the ring, he should see it on a smaller ring. Right. So let's go forward and show what I mean by this case with a near source, right? So I'll talk about that as we come back and forth. First, let's talk about the reason why we are concerned about this general relativity, and reason why relativity has failed these previous tests already. If you look at the impact parameter, right, the gravitational bending is a function of impact parameter in plasma free space. This is where relativity has a problem. So I will go forward and talk about this impact parameter. Let's go back and review what we just talked about. And the impact parameter is very simple. And you know that the radius of the sun, given the radius of the sun is approximately, what is that? The radius of the sun is approximately, what's it? I think it's 960. Well, I'll give you the exact figure. It's a couple of thousand many times the radius of the Earth. So if you're given the radius of the sun, if the radius of the sun were r, and the impact parameter of light ray is hitting the rim of the sun, the impact parameter in this case is r. So let me get my pointer back again, so you can see what I'm talking about. So the impact parameters for this light ray is 1r, right? And one times the radius of the sun, right? That's the impact parameter of this ray. So if I have another light ray going to a larger circle, right? A Gaussian circle which has exactly twice the radius of the sun, the impact parameter would be 2r here, and so forth on out. The impact parameter for this light would be 3r, 4r, 5r, and so forth on out to nr, right? So in that case, if you work out the geometry and the physics, the mass that is enclosed would be the same for all of these spheres, right? So the Gaussian sphere, right, increases in its radius, right? But the mass enclosed is the radius of the sun. It has the same radius, same mass, but different radius, right? For an impact parameter that is twice the radius of the sun, the light bending should be exactly 1/2 of the light bending what is detected at the solar rim, right? So this would be 1/2 of light bending for twice the solar radius and the gravitational field, because the gravitational flux at this surface of this sphere, right, is the same as the sun, but given the 4 pi g times m divided by rc squared. If I increase r, we decrease the gravitational deflection. So the gravitational deflection is a function of 1 over r times whatever the gravitational deflection is at the surface, right? So it is a 1 over r effect, not over 1 over r squared effect. This is the gravitational, the light bending is a 1 over r effect. So some people have been confusing that the gravitational bending, light bending of relativity being an inverse square effect. That is not correct. We shouldn't teach that in school, because what happened, the gravitational deflection of the sun based on general relativity, it influences the light ray approaching and the light ray receding. So there's a gravitational pull on this whole ray as it approaches, and also gravitational pull on the ray as it recedes. So this whole ray is being influenced, according to general relativity, by the gravitational field of the sun. And on its approach, there's some bending here, and on its receding, and there's also some bending, and the total bending should be this angle here. So let's go forward, and I'll show you some examples. All right. Given the fact that what we see out in deep space, when we go above the solar limb, right? So far in deep space, there is no evidence of light bending past the solar rim of the sun, going out into deep space where there's no plasma field at all. That is a fact. And I have observational evidence showing this is the fact. And you can do some tests, look at what is being going, look what's going on in deep space when you have a star-filled sky. Where are the Einstein rings? So if the Einstein rings are not there, If you look at all these stars in the star field sky in deep space, there are many stars out there where you have one star in the forefield and another star in the backfield that is exactly in the line of sight of the observer, which is here on Earth. We see no Einstein rings. So that gives you evidence to the fact that if these stars out here, all these stars are shining, and if you have an observer so far back in this direction, looking past, he sees no Einstein ring. Therefore, this has to be correct. So let's go forward. So summarizing what we just talked about, you have the solar plasma limb of the sun, right? And you have a bending effect being observed right here by the observer. Since the deviation of that light rate, approximately 1.75 arcseconds observed, and no lensing whatsoever observed out here in deep space. So we'll go forward again. So let's take what we just build upon in the past, let's say the past 10 slides. We build upon the following. We have the observational evidence. Now we'll talk about the observational evidence from this point on, what we have observed thus far. If you have the observational evidence, it has been predicted by some astronomers who have the hopes of going out into deep space. They want to use the sun as a lens to see some distant objects out in deep space. So if you can put a satellite up and send it out into deep space, if the gravitational deflection of the sun is according to what general relativity states, if general relativity states that the light bending from a distant star coming past the solar limb of the sun would deviate 1.75 arcseconds. If this light ray is bent down coming past the sun on a 1.75 arcseconds, bending down, right? And this other light ray coming past the solar rim of the sun, it is bent up, going past the sun, right? Eventually, these two light rays will come to a point. And if you go far enough away from the sun, from the center of the sun, going out into deep space, if you go 550 astronomical units away from the sun, where one astronomical unit, if I only go one astronomical unit, that's the orbital radius of the Earth, right? If I go 550 astronomical units past that, that's the big distance. That distance is primarily about 17 times the orbital radius of Pluto. That's pretty far out. So the focal length of the plasma of the sun, at the plasma of the sun, one star that has one solar mass and one solar radius, like the sun, for an example. Our sun has a plasma focal length of 550 astronomical units. That means if I put a satellite out here in deep space and look back towards the sun, any star so far towards the left, if I looked at the star towards the left, placing an observer right out here in deep space, and if he sees the sun like so, he should see a plasma at the plasma solar length, 550 astronomical units out. He should see a thin Einstein ring of a distant star behind the sun. That star would be more than 550 astronomical units going in the other direction. So he should see that, right? Now, taking this same image, what we just showed here, taking that picture and make that picture smaller here, right? Here's the sun, and here's 550 astronomical units going away. So I just compress this whole picture down to this right here, right? And the observer sees this Einstein ring here going past here, right? If I go out twice the solar radius, right, and a star and backfield towards the left passes by the sun, and if it does not deviate, there's no deviation whatsoever. But if this happens, right, then what happens is the general relativity is history, right? The relativity will be dead if this picture takes place. But however, according to the prediction of general relativity, relativity says the light should be bent to 550 astronomical units away from the sun. These light rays will come to a point. But taking 2 astronomical solar radius of a Gaussian sphere, if that radius were twice the solar distance, right? Twice the solar radius, right? For a sphere, and these rays were such, then these rays would have to go not only 550 astronomical units away, it would have to go nearly 4 times that distance away. By double the Gaussian sphere, then I quadruple the distance out here. So you have to multiply 4 times 550 astronomical units away. That's a pretty big distance, right? So if I make this sphere 3 times as much, then these light rays will have to go so far out that it would be 9 times the distance. So there's no evidence that Einstein rings from an impact parameter will behave like this. We look at the distant stars and we can see this already. Our sun, stars like our sun, are placed out in deep space right now. We look at the stars, and the many stars out there, that some of these stars are bigger than our sun, more heavier than our sun. They may have a radius that are smaller or even bigger. There's some stars that have much smaller radius than the sun and much more mass than the sun, and they are actually blue stars. They're about some to 100 to 1,000 times hotter than the sun, and they're more dense than the sun. But there's stars all over our deep space, like the sun. We see this all the time. But however, we have not seen this picture at all. This picture is not visible anywhere looking at the deep stars in our space around it. When you go out in a clear night where there's no clouds, no rain or nothing, you see all the stars in heaven, all the stars in our background field. What we see is this, but we do not see this. We can't see this anyway because we're not close enough to the stars. We're too far away. So, but we are out here someplace. The nearest star to us is 4 light years away. And at 4 light years away, we are out here someplace. If we were only 550 astronomical units away from a star like our sun, we may see an Einstein ring around those stars. You know, traveling around in a spaceship, you get close enough to the star, you may see an Einstein ring. But going far out here in deep space where we are, we should see these rays coming to a form. If relativity were true, we should see this. We should see Einstein rings all over the place. So this is my picture here. I'm showing this observational evidence that relativity has failed already in this case. So this is the observational evidence. I'm showing that here at 550 astronomical units, which is the Einstein ring, but however, only at 550 astronomical units. But beyond 550 astronomical units, if the Einstein rings are not there, then relativity should be history. So what I'm going to do, I'm going to pause here and I take questions on what we have thus far, showing the observational evidence, and I summarize what I just said there with the observational evidence, given the fact that you have one solar radius, 550 astronomical units, two solar radius, 4 times that, at 2,200 some astronomical units away, 3 times that, a Gaussian sphere, 3 times that, it would be 9 times this much. So we are approaching at these distances, we haven't even approached the nearest star yet. The nearest star from us is 4 light years away. So it's much beyond 4,950 astronomical units. So I'll just take any questions that you may have on this so far. So we just
Okay.
generalize questions.
Hopefully everybody can hear me. We're opening it up, and our protocol is to raise a flag and unmute yourself when I call on you. The first flag was Glenn Baxter. That was up a while ago. So Glenn, if you want to say something, you're first. And then Nick has one after that. And that's it at this point. So Glenn, go ahead. No? If
Very
not,
good
Nick. Okay.
Very
Nick,
good present.
go ahead, Glenn.
This is Glenn. Can you hear me okay?
You're a little light, but go ahead.
Okay, Dr. Dowdey, very good presentation. Do you have any comments on Pioneer 10 and 11? That's question number one. And number two, do you have any comments on Ether?
Yeah, on the Pioneer 10 and 11, for the past, let's see, gosh, decades now, we have been observing those satellites that have gone in deep space past Jupiter, past Uranus, and gone further out. We know now that there are objects out there that have a gravitational tug on these satellites. And what we are learning is that we thought we understood all the perturbation effects of gravitation. Most of the perturbation effects in our solar system, our moon, our Earth, and the astronauts and all those things are being tugged by Jupiter. Jupiter has the most profound effect, and then you have Uranus and the other large planets. But these satellites are telling us that there's some other objects out there that's giving gravitational tug on us, right? And it's probably pulling our sun, the earth, and everything else. That means that the solar system may be much more complex than what we thought. There may be some things that are happening that with gravitation that we don't have the full picture, right? And one day we maybe go out with some more complex telescopes and get away from the Earth orbit. Around the Earth orbit, we have a problem with the Earth orbit is that there's a lot of particles and asteroids and there's a solar wind, there's dust and all kinds of stuff coming from the sun. If we can go further away from the Earth orbit, we may be able to see more things. And as far as the ether is concerned, Einstein back in 19 what was it 1908 to 1913, Einstein did not like ether, and you had uh, the Pauli experiments and all these experiments with Michelson and other experiments, they sought the ether effect and they had the interferometer setups and they thought that perhaps maybe if you have the orbit of the Earth about the sun, and they would see some things based on the motion of the Earth and maybe the motion of the earth about the sun and so forth. And that was not there. So the thing here is you have the emission series. I'm in the emission series, right? And in the emission series, you have I assume that some things we can't be arrogant. And as far as I'm concerned, I'm very keen on this thing, arrogant. When you step in the laboratory, as soon as you step in the laboratory, you've already interfered with what it is you're trying to measure. You take a drop of water, for example. How do you measure the temperature of a drop of water? You stick the thermometer in a drop of water, you've already cooled the drop down a little bit, right? So you can't, anything we measure, we interfere with. So with the ether theory, if there is uh, uniferous ether out there or some kind of a medium that undetectable medium, sometimes we can't measure everything. We can't, we are material ourselves. The fact that we are doomed, we think about measuring some things that's out there just because we can't see it. That does not mean it's not there. So therefore, you have there is maybe substance that we can't see or detect. But me being in the mission series, I believe that if you go back to the fundamentals and you hold on to the fundamentals, but you got to hold on to it, and maybe you can observe some things based on that. Okay.
Okay, thank you. I see Dr. Lucas is going to ask a question too. I'm looking forward to hearing that. Thank you very much.
Yeah, I think
Okay.
Nick is next. So Nick Percival, if you want to turn your camera on so we can see you while you're asking your questions, that'd be great. So, and then Bill Lucas is after that, and Francis Fernandez is after that. So, Nick, are you there?
I'm turning it this side because the tube light comes. No, you come this side. Yeah, come this side. You come.
Oh,
Take my
hey,
shoes off.
Francis.
Hello. Hi, this is Nick. Can you hear
Okay, go
me?
ahead, Nick. Yeah, we do
Um,
hear you.
First of all, great presentation, Ed. Um,
It's only half
I
done.
I wanted to comment that I put into the meeting chat the fact that Uh, the mainstream, the people who've done the best measurements on light bending around the sun, their data confirms your thesis. And I've put in the URL to their chart about how, where they show what general relativity predicts versus the empirical data. And it shows that near the sun, where there is the most dense plasma, there's kind of a general agreement with general relativity. But once you go beyond 2 or 3 impact parameters, then it's way, way off. So they confirm exactly what you said, Ed. Good work.
Right.
I have a question. I'm in agreement with you about general relativity's model of space-time, and space morphing into time and time into space is not good. But knowing GPS does seem to confirm that the rate of clocks varies with gravitational potential. Now, that doesn't mean that general relativity is right. It's possible for, a theory to be partly right and partly wrong or whatever. But I just wondered if you had any comments on that particular topic.
Yeah. Yes. And if you go to my website, you can go to my website, extinctionship.com, and you can go to the significant findings. And I have a page on there that shows a lot of pictures showing you the gravitational potential gradient of the sun, the earth, and the moon. Now, as you put an atomic clock here on Earth, for example, you got this thing running on the ground, right? And it's keeping good time. You have a very accurate atomic system that's tuned to the Earth, right? And you put that same clock in deep space, right? You get it away from the Earth, go out in space. What happens that you'll find that the daggone thing speeds up, right? So I'm going to go to my website, and you guys can. I don't know if you can click on the website now, Greg. Can they click on the website at the same time? Is that possible?
I believe so. Don's got it here in the chat. No, extinctionshift.com.
Yeah, extinctionship.com, right?
There it is. I mean, you can't just click on it. You have to highlight it and then paste it into a browser. But
Oh, I see. But so they can go to it. I don't need to go to it, but they can go to it. Maybe they have another computer somewhere sitting there, and you just click on it. And what you do, you click on what is the significant findings. Click on that, and I have some images down there. And what I do, I just talk through those images, right? And go down to the significant findings on atomic clocks, and I have it right here. And what I'm gonna do, I'm gonna point my camera around. I'm gonna do this thing again, Greg. I'm gonna point my camera at it. I'm gonna take my camera and point it at my screen. I'm gonna show you some things.
okay, Ed, do you want us to see your screen? Is that what you want to do?
Well, I can point my yeah. Well,
okay. Now here's what you do. Now listen to me.
Here's what I do. I have another computer. I'm not using the same computer today. I'm using a different computer. You see?
Okay, but do you want us to see your screen? That's what I'm asking.
Oh, you know how to do that?
Yeah, I'm going to tell you in a second.
Yeah.
All you do is just go up into the upper left corner of the middle area where there's a little house. Click on that house. Do you see it? That's home.
Click on the house. Okay, but that will let you see the screen.
Hang on, that's the first step.
Wait a minute, Greg. Wait, let me say something. That will let you see the screen that I'm using for the fuse meter. See, I'm using one computer for the fuse meter.
Well, yeah.
Then I got another computer I'm using.
Then I guess what you can do is just take your camera and point it at whatever it is you want us to see.
Let me take my camera and point it around here.
Okay. There, all right. We'll do it that way.
Great, but get all my top secrets and everything, man. Yeah.
This is high tech.
I gotta be careful with you, man, because you slick. Yeah, okay, here's what I'm gonna do. I'm gonna point the camera at my screen here, and maybe you can see this. Now,
Zoom in, get in a little closer. It's pretty
I'm
far.
gonna get a little closer.
Yeah.
Now, what I'm gonna show you is that here you have the sun, right? I'm gonna use my pencil as a pointer, right? Yeah, that's the sun right here, right? See, that's the sun,
Yeah.
and
Can I just stop for a second? If you want to see it bigger, that's kind of small. In the upper right corner of the video panel on the side, there's
mm-hmm.
a little button that you can click. I don't know, it's got a funny little icon, and then it expands it. You can see the screen much larger. And you
Oh
can,
yeah.
I'm looking at it
Let me
myself. Just letting
let me see
everybody
that.
know that way, because it's hard to see it so small. Now we can
Okay,
see it. Okay.
okay. Let me do this. You may be able to see it better now, right? How about that?
Yeah, that's great.
Okay.
If I
Now
undo
here,
myself, then you may, yeah, now I can see it even better.
now
Okay.
see. Now here's the sun, right? Now here's a graph, right? This graph points down, right? And this one goes to the right. That's the distance out here. That's distance, right?
Mhm.
And this is the sun. Now, if you take the gravitational potential, notice as you go out here a distance away, the gravitational potential is a negative number, right? You see, it's a negative number. As you come closer to the sun, it goes more and more negative. It gets bigger and bigger negative, more negative. Then it goes down to a very big number negative. You see what I mean? Right? That's the sun, right? Now here's Mercury right there. That's Venus and there's Earth. You see? Okay. Now let's take this little block right here where Earth is, and we're gonna blow it up. We blow that up to this block this big, right? Now here's that gravitational potential right here. It's going through you got that little block there? That's the gravitational potential down here, blown up. Guess what? The gravitational potential of the sun is nearly 14 times bigger than the gravitational potential of the Earth, at the surface of the Earth. The sun had I'm talking about the gravitational potential now, right? Not the gravitational gradient. There's a difference between gravitational gradient and gravitational potential. Okay? So it turns out that the gravitational gradient of the sun is very small in comparison to the gravitational potential gradient of the Earth. And what is gravitational gradient? Let me show you what that is. Okay. So I'm just going to scroll up and show you what I mean by gravitational gradient. So over here. Now here's the Earth. You can see that, guys, right? Here's the Earth, right? Okay. And here's the orbiting satellite, right? And you see these gravitation, you see these lines, okay? These lines are pointing down at the Earth. Notice that these lines are not parallel, all right? And here's the gravitational gradient field, potential gradient of the Earth. And if you take a look at the gravitational gradient of the sun is so far away, 93 million miles away, right? Those lines would be parallel coming from the sun, right? But since these lines are not parallel with each other, this gradient is what affects these atomic clocks. It turns out that the gravitational potential gradient of the Earth affects atomic clocks much more than the sun, even though the gravitational field of the sun is bigger, but the atomic clocks are affected by gravitational gradient. You know why that is? It is the gradient field of the moon that causes the tidal effect on the Earth. The moon causes the water to stand up on one side close to the moon and also on the other side because the moon has a gravitational potential gradient because the moon is closer to us, right? So those gravitational lines are not parallel coming from the moon. The moon affects the atomic clocks more than the sun, and that's another thing that did some measurements on. So that's what I wanted to say about that. That's my comment on that. All right. So is that clear? Right. So I want to make sure that's clear.
Yeah, I think that's clear.
Any
Hope
more
everybody
questions?
saw it.
Mm-hmm. And then keep in mind that the gravitational potential of the sun is 14 times bigger than the gravitational potential of the Earth at the surface of the Earth. But the gravitational potential gradient of the sun is almost zero. It's just 1,000 times less than what the Earth is, right? And so it's the gradient of the Earth that causes these clocks to slow down when you put them in the deep orbit. So I'm gonna show you one more picture here. These equations, right? The gravitational potential gradient of the moon is twice the gravitational potential gradient of the sun. That's a calculation. You can verify that. Now, the gravitational potential gradient of the Earth, you see this equation here, right? Is 1.6 times 10 to the 3. In other words, 1,663 times bigger than the gravitational potential gradient of the sun. You see that? So that's why the Earth is affecting the atomic clocks, right? And this is what's going on. And this has nothing to do with relativity whatsoever. It got nothing at all to do with relativity. But the gravitational potential the gravitational potential of the sun is bigger, far bigger than the gravitational potential of the Earth. But the gravitational potential gradient of the sun, right? See this down here? That's the gravitational potential gradient of the sun. It's almost zero in comparison to the gravitational gradient of the Earth. See? So this is what's affecting the atomic clocks, right? So I looked at this whole field, and that's basically what I have to say on that. So you can go to the website and you can see this. It's clear, you know. So it's
Thank you, Ed. I did have a follow-up question.
Okay.
That's kind of deep, and you know, if you haven't thought about it, we can just move on. But I was wondering where, you know, general relativity, particularly for the law of gravitation, went wrong. Like in special relativity, it seems all the paradoxes and problems come back to the fact that the second relativity principle, the constancy of the speed of light principle, was wrong.
Mm-hmm.
Once you have one of your two basic principles as wrong, you know, everything else kind of goes down the wrong track. Now, but that didn't seem to play a role in Einstein's deriving the law of gravitation per se. So I wondered if you had a feel for where did Einstein go wrong in developing that law of gravitation?
I believe Einstein was I believe that Einstein was influenced by some of his professors, and they have what is called the equivalence principle.
Right.
And one of his professors believed in the equivalence principle, and I think that influenced Einstein. He had a great influence on that. And the equivalence principle is something different than the reality. So if you believe in the equivalence principle, you have to deviate from the reality a little bit. And not everything is straightforward. Not everything is you know, like we want to be. You know, we can't have the attitude that we can go around and dictate nature, right? You can't tell nature, you know, if you step off the top of a building, you're going to go down, right? You can't tell nature to stop, you know. So you're going down, right, and you're going to hit the ground pretty hard. But when you drop something, these things are going to accelerate. Now, you can cause acceleration by putting somebody in a closed box and turning on a rocket motor, and you accelerate it, right? And you can stand on a scale and probably weigh yourself, you know, on the scale in that box accelerating. You will not know the difference between an accelerating using a rocket motor or if I can make the motor silent, you know, so you won't hear it. Would you know the difference between an accelerator and a gravitational field? The experiment, could you do an experiment inside of a box and determine whether you're dealing with a gravitational field or are you dealing with an accelerating body that's accelerating you in deep space? Is there an experiment that will let you do that? I'm asking one of you guys. Maybe you guys can tell me.
I believe there is.
You think there is?
Yeah, and the difference is in the gravitational gradient, what you were just talking about.
Yeah,
Because
right.
an
Exactly.
acceleration
Exactly.
It's going to be just all the components are going to be parallel, but
Right.
in a gradient there's going to be a slight divergence, if you will, in one direction.
Right.
So that's how you know.
Did your wife tell you you theoretical man? Great. He dreams theory, man. He
That's
writes
all
all
I
this
ever
good
do. That's
stuff.
all I think about.
Oh my goodness, man. Yeah. But that's the thing about it. You have to do an experiment if you have a big enough laboratory or box where you can put some sensors up and you can experiment. Now, one thing that bothers me, let's say you're traveling in deep space and you're in a spaceship. You're traveling in deep space now. You're in this spaceship, and what happens is that uh, if there is some object out there that you got to be aware of, like a black hole or something that's going to suck you in it, right? How would you know that if you're in this spacecraft, right, and you're just floating around, getting your breakfast and everything, and then you got some water. You got to drink the water with a straw. You can't open the top because the water will float out in the spacecraft, right? So you got to keep the top closed, right? And like a bag of tang, that's where you got to drink. The astronauts are taught to drink like that, right? So you can't open fluid out in the spacecraft. You can have a mess all in the spacecraft, right? So you have water bubbles floating all over the cabin, right? But what if you're in the spacecraft and all of a sudden you felt something, tugging you, and this water droplet, one started going to the right and the other one started going to the left, right? Then you know you're in trouble, right? You see what I mean? If you see that happening, something's going on. By the time you feel something tugging you, and you got a gravitational gradient, how did they line the spacecraft and orbiting around the Earth? What they do, they put a long pole on it, right? And what happens to the long pole, right? It starts aligning up with the Earth's gravitational field, right? It'll start pointing at the Earth because the Earth has a gravitational gradient potential, right? And these poles will line up, and it keeps the satellite pointing towards the Earth, so the camera was always pointing at the Earth, right? Or you have another camera that's pointing at the star going above. It keeps the satellite from tumbling around. So they put a long pole on it. That's called a gradient. Uh, they call it a spaghetti faction or something like that. If you put spaghetti in space, and long spaghettis, right? Guess what? If you wait a while, all those spaghettis will start to line up, and they're pointed in the direction of the gravitational gradient. And they
And
see that going on all the time. The astronauts like to experiment with stuff like that. They throw these little macaroni, get this thin macaronis in a box and throw them in a spacecraft and let them float around a little bit, and then they start lining up, pointing towards the Earth. Right? That's how you measure gravitational gradient. Right?
But okay, so but
Ed,
they
I
they
think
look pretty parallel, don't they? I mean,
Yeah, they
you have
look
to
pretty
be
parallel. Yeah.
you'd have to have some really fine spaghetti to be able to tell the difference. But
That's right. That's right. That's right. And you got to know what you're doing too. If you're floating around here, you're being pulled towards a black hole. If you
uh,
feel something, it's too late for you to do anything about it.
yeah,
Ed,
Because
I
you
think
spaghetti
don't
I
have enough
cooked it
energy
probably
to
wouldn't
escape.
work. Sorry,
Ed, I
Nick. Go
think
ahead.
that's a good insight, and I think you're right that it was the principle of equivalence where things started to go wrong. Thank you very much, Ed.
Right. Okay.
Okay.
Very good. Very good.
Well, this Q&A is taking us into the next hour here, but all right, I think Bill Lucas is next. Dr. Lucas, go ahead. Are you there?
Yes. I was going to put in a plug for a future presentation. Um, there was questions about Pioneer 10 and 11, and
Yeah.
as you know, in order to adapt or rescue general relativity theory for the velocity of the outer spiral arms of spiral galaxies, they invented dark matter. And so you can describe that data with the dark matter. But when you look at Pioneer 10 and 11, that doesn't work. And
Right.
so you've got an inconsistency. If you take it in one place, you don't get it. So anyway, in a future presentation, I will explain how Mach's principle allows you to not need dark matter at all, and how nobody really takes it properly into account. And I show how to take it into account.
Yeah,
That's 3 weeks from today.
yeah, that should be interesting. Yeah,
Okay.
that should be interesting.
And
Man.
then Francis Fernandez is next. So Francis, are you there?
Yeah, yeah.
Awesome.
This was an observation which we saw one night at a night camp with a lot of college kids, and the night sky was covered with stars. It was a dark night with no interfering lights from tube lights or from bulbs, and we had laser lights, a torch, and a regular bulb. And when we switch off the torch, we don't see photons moving on. We don't see the laser light moving on. So the kids raised a question, and the question was, are photons really traveling? If they were traveling, then when both torches were switched off, the laser torch and the bulb torch, then the photons would be seen moving like a comet, but they don't. The beam ends and stops when you switch off the torch, which means that photons are not traveling. How would you explain this argument?
Now, when you say you have a torch, right?
Yes.
Is it a hot torch in air?
No, it's a light bulb used in camps,
Mm-hmm. Okay.
and shine it towards the sky, and you see
Mm-hmm.
a ray of light.
Mm-hmm.
But when you switch it off, you don't see the ray moving.
Right. Now, one of the things that's going on there, you have a, a device that's emitting light, and when you emit light in a atmosphere, you cause emissions coming from molecules that go through transitions, and they emit. Right. What you have emitters, right? You have thousands of emitters, right? It looks like a constant beam, but you're emitting and re-emitting. But however, if you have a light emitting diode, for example, and you energize a light emitting diode, that will work in a vacuum, right? But this, I got a feeling this thing would probably not work in a vacuum. You can't do that experiment in a vacuum, right? You have to have something that would re-emit, right, or cause some transition to take place in the atmosphere, right? Now, for
Well,
example,
the question
yeah.
was, when you switch off, we don't see photons moving on.
Mm-hmm.
Means
All
from
right.
the point, the
When you
point
say
at which the
when you
light
say
bulb.
switch off, what is the
Yes,
switch? When you turn the switch off, what are you turning off?
we are turning off the light.
All right. You're turning off
And
the
when you
light.
turn off the light, you don't see photons moving on in space.
No, okay. Now, my question is it possible with all the advance in science, all the advancement in science? I had some arguments with guys at NASA Goddard when I was at NASA. You argue with these guys, and some of these guys, they may know how to mix rocket fuel, but I don't know if they know anything about physical science, man. Now, they put satellites in space, and they know how to load a vehicle up and put it in a certain orbit. But arguing with science with some of these guys, something else. And there's a couple of guys in there was talking about photon interaction. I don't believe a photon can interact with another photon. Then again, I don't believe we can observe a photon without interfering with it, right? So they talking about, photon counting. They put these devices in deep space that have uh, a photocell in it, and these photocells are so sensitive they have to be sensitive enough to detect light coming from a distant star and distant galaxy. By the time you get to Earth, some of these distant objects that they're trying to see in space are so weak in light emission, you have to have light amplifiers. Otherwise, the modern telescopes will not work. So my question is, can you see these photons? Are you actually seeing photons? Or are you seeing something else, right? that looks like a photon? Do we know what a photon looks like? That's my question.
Yes, I think what I'm trying to get at, which none of us can answer, is what happens in between from emission to transmission to
Hmm.
observation to impinging on another target substrate, whether
Now,
it be the eye or a camera.
now,
So I think there's a big gap in our understanding there, and a lot needs to be done. And,
that's right.
and then that comes back to the question of what is a ray, because
Mhm.
when we are talking about lensing, we are making statements of rays when we don't know what that ray really is and how things are moving.
Now, my belief is that I'm in the mission series now. I'm in the mission series, and I believe that the only emitters that we know of in our physical science world are called dipole emitters, and a dipole can receive a photon, absorb it, and it could also re-emit a photon. So I believe that when you make a measurement, you kill the photon. The primary photon is dead. So what you have is a secondary photon. And that secondary photon, for example, you got a window in the vacuum, right? Here's the photon that interacts with the surface of the window, right? And that surface of the window completely absorbs that photon, right? And now you have a secondary photon propagated inside the window medium and has an index of refraction, right? It's propagating inside that window medium, right? And it has another velocity inside the medium. Then it interacts with the other surface of the window, right? And going back into vacuum again. And when it leaves the surface of that window, it goes back into vacuum. Then it goes back into the vacuum propagation velocity, right? If the window moves, then it's Galilean transformation of velocity. I don't believe in Lorentz transformation. So it's emission series. The primary photon cannot be. We can neither measure the velocity nor the wavelength of a primary photon, and that's my theory as an emission theory.
Okay, thanks.
All right. Boy, I could, just for whatever it's worth, I'd love to spend some time talking about the idea of a photon not moving. I think that that's actually something that we need to
I,
seriously
I believe
consider.
I believe that's
But
possible, Greg.
we're not gonna go there because that'd be another 3 hours.
I believe
Uh,
that's Greg. I believe that's possible because it depends. The question is asked: who's moving? Are you
right.
moving, or is it the photon moving? The photon could be
Exactly.
standing still, and you're moving with the velocity of light. You
There you
see?
go.
You see?
All right. Harry has a flag up, and then we'll go on with part two after Harry. Harry, are you there?
We only did part one? My goodness, I thought we were talking here.
No,
Okay.
no, I know there. It's well, maybe we'll do it in two
I
sessions. I don't know. We'll see.
I have to admit that I've heard this before, and it seems like it's a repeat. My question goes sort of to this. As far as I'm concerned, it seems to me that this light bending issue has to do with the four-dimensional aspect of space. So does, and I got a couple of issues here. So my first question, and I'll ask a second question. My first question is, does this work that you do you think this disproves the four-dimensional aspect of space, which general relativity has to assume? In other words, does this prove that their assumption that there's four dimensions to space, is that wrong?
Now, I'm gonna give you a very simple answer to that question, right? Now, I'm gonna give you an example. Let's say I'm in my office space and I'm minding my own business, and you're in your office space, you're minding your own business, not bothering anybody else. I mean, Greg may be in this space, he's minding his own business. I'm in a mission series, right? Now, when you get to four-dimensional space, general relativity, Lorentz contraction, and Lorentz geometry, and all those guys, they're minding their own business in that space. When Einstein sets up to do something, and you're doing general relativity, you're minding your own business. Once you do a time dilation or length contraction or something like that, once you do that, guess what? You're gonna have to relativistically correct the mass you got to do something about the space around you. You got to warp the space. In other words, if once you do one, then you got to continue in that space to do your calculation. You're sitting there minding your own business, and you might get an explanation for a physical observation that something you just observed. I'm in my space. I'm in Euclidean space geometry, right? And in my space, when they talk about black holes and all that, you tell the students that the black hole, the gravity is so intense that the photons can't escape. I wouldn't say that in my student, right? I wouldn't say that in my student. And the professor in my class working for me, if he told the student that the gravity is so intense and the light can't escape from it, I fired, you know. He's terminated, right? I said, look, if an object out there has so much gravitation, right? Gravity overtakes everything, and you have what is known as a gravitational collapse, right? And there's so much gravitation, right, that then the physics that we know of has been terminated, right? There can be no dipole. There can be no physics that we know of. There can be no vibrations inside of a black hole. So there's no light emitted from a black hole. That's as simple as that. It doesn't matter emit any light whatsoever. So therefore, this is why it's all black and dark. So my thing in my space, I'm in Euclidean space, and my velocities are additive, right? The C prime does not equal to C plus C does not equal C prime does not equal to C, and you have C plus V, and C prime is equal to C plus V, and there's no bounds. C prime is unbounded, but in Euclidean space, in general relativity, C is constant in all frames of reference. So therefore, I believe there's no evidence for that. And that's what we're seeing in deep space. I believe we are seeing a Galilean university. That's what I see.
Well, I guess my question, it didn't really help me. My question is, what we're dealing with here is empirical evidence. So you have a claim, you have a theory called general relativity, which the mainstream or the establishment science people are promoting as the correct theory and the only theory that can be permitted. And to me, that's a problem. Okay, so now we have, they've already claimed that this is proved by some evidence that they have already done. So they say this light bending due to gravity is a fact and it's proven, and you're saying that it's not. So I see that as a problem.
Let me make one comment. You cannot prove a theory. It's impossible to prove any theory. One theory cannot prove another theory. There's no experiment that can prove a theory. A theory can only be invalidated by experiment. Experiment disproves the theory. So general relativity has already been disproven many times over and over again. The problem here is it's going to take one of the guys like us.
They're not using that philosophy of science. They're using the philosophy of science that they proved that
Say again.
Their philosophy is they take it that they did the experiment and they found the bending, the changing of position of the stars in accordance with the predictions of the theory, and so general relativity is proven by that evidence. And it looks to me like you're saying that.
When they say general relativity is proven, they're wrong, because you cannot prove a theory, with an experiment. It's no proof. It's only a theory. And it's stands to be disproven by experiment. Experiment can only
validate. You agree on the fact that that's the position that they're taking?
Yeah.
Okay, so they are taking the position that light bending evidence with respect to solar eclipses is consistent with general relativity. And as I understand it,
the number of relativists that are finding problems with it. This is why they're going out in deep space trying to find some other things that can support relativity.
That's confusing to me. So I'm not really sure what your presentation is trying to do. Let's just go back to the beginning.
Let me stop you for a second. Let me ask you my question.
That's so easy.
Let me get this straight. I want to straighten this out. My presentation has to do with general relativity. I'm not talking about my theory at all. I'm bouncing the observational evidence against general relativity. That's what I'm doing. Everything you see me on this day, what I've talked about here today, is doing with the theory of general relativity based on what relativity says. I'm bouncing only the observational evidence against relativity. And all this stuff are the fundamentals. Gauss law and
I understand that.
light
So
bending
what's
and all that stuff.
the problem I have with this presentation is that to me it's confusing. I would just like to see some simple conclusions and simple
No, I'm
statements
not done
of
yet.
what
I'm
it
not
is
done
that
yet.
you've
I'm
done.
not done yet. I'm not done yet.
You're not done. It's already
Are you
way
done
you
too
yet?
see the
long, in my
did
opinion.
you see the beginning of my presentation? Did you see the
Okay,
beginning of it?
my question is this. Okay, if you disprove this light bending evidence, in other words, if you show that their light bending evidence that they claim exists is not true, and you show that there is no empirical support for the light bending, does that mean that there is no evidence for a fourth dimension in
Now,
addition
now you're
to
asking.
including in
See,
three dimensions?
you're asking two different questions. You're stating two different things. I have
No,
not
I didn't.
mentioned.
I'm asking
Wait a
you to
minute.
summarize your result in a
Let me
simple
say.
way.
Let me say that. Let me say this. Let me say that. When you say fourth dimension, and you're putting in Galilean transformations and all those other things. When you talk about Lorentz transformation, you have to go to fourth dimension. You have to go to this other fourth dimension. And relativity is based on fourth dimension. Relativity, if it weren't for fourth dimension, relativity would be dead. So I'm bouncing the observational evidence, which I have done against relativity and the fourth dimensional concept they're talking about, and the Watt space and all those things, right? That's what I'm doing, and I'm going to show at the end of this presentation. I'm going to go to the center of our galaxy, which is called Euclidean, which is called Sagittarius A, and show where there's no light bending whatsoever.
Get 35 on today.
Relativity should be dead in the water with that. So you'll see that in a few minutes.
Well, my question is, does light bending depend on there being a fourth spatial dimension, not a time dimension, a fourth
Now,
spatial dimension?
the answer to that question, in all due fairness, is there a fourth dimension? Is there in reality, in
Well,
our existence in the universe, is there a fourth dimension? Right? The fourth dimension is
that's
only
what
a
I'm trying to
theory. That's
ascertain.
our
Hey, Ed,
basic understanding.
can I jump in for a sec, Ed?
Yes, go on.
I'd just like to say this is my own 2 cents worth, and that is that there is two questions. I mean, one is what is the empirical evidence, and how do we interpret it? And Harry, you're asking the question: can we interpret this empirical evidence? Or do we have to interpret this empirical evidence with the fourth dimension, or do we not? And my answer would be, I think we could come up with theories that have a fourth dimension and theories that don't, and they would both claim that they explain the evidence. I think that's possible, and so
Right.
it's really a tough question to answer. Ed is just saying that there's problems with the theory as it currently exists, and
Right.
that's all he's saying. Am I right?
I'm saying there's a problem with general relativity. There are other
Right.
theories out there, but
Okay.
right now I focus on one thing at a time, and that
Yep.
right now is general
Okay.
relativity bounced against the
So yeah.
observational evidence.
So could they take say, all right, we can explain this using the fourth dimension, and other people saying we could explain this without the fourth dimension,
Well, the
and
relativity is fourth dimension.
we'd be here all day long, and
Yeah,
we would
but
never resolve that question because that's a theoretical question.
yeah,
So
but
I don't
relativity
know if
is
that
fourth
answers
dimension.
you, Harry, but that's the best I can do.
Yeah.
Well, that's not really my question. My question is,
Okay.
does this light bending issue, in other words, does light bending depend upon the assumption in general relativity that there is some kind of fourth spatial dimension or not?
I would have to say, I had to
Yes,
do
David,
another
we're
flavor
yep.
on that. You can have light bending without general relativity whatsoever. There could be light bending in
That's not
plasma
what I'm
space.
asking.
It has nothing to do with general relativity at all. Nothing.
All right.
right?
Okay,
Okay,
I
I think
guess
we
Okay,
need to move on
let's go.
because Ed has actually only halfway done. And you know what I think we're going to need to do, Ed? I think we're going to need to do this in two sessions because we're already an hour and a half in, and there's no way you're going
I
to.
want, who was the gentleman that's on just then? Did
Is
he
that
see the
okay with
beginning
you?
of my presentation?
Huh?
Did he see the beginning of my presentation? Because I answered some of his questions in the beginning. I
He
don't know if
must
he
have
saw the
muted
beginning of
himself.
this or not.
He must have muted himself. Uh, that's all right.
Okay, well, let's
I
go.
think he was here pretty close to the beginning, so I don't
Okay.
know.
All right.
Uh, Neil Adams is here. Hi, Neil. Glad you could join us. Okay, well, I leave it up to you, Ed. You decide. But as it is now, we've got less. If we want to have questions and answers for the second half of your presentation, there's no way we're going to get all that in half an hour.
Okay.
Greg, are you
Okay.
recording?
And besides, yes, I am.
Okay.
And besides, I think we need to spend a little bit of time talking about some of the issues with the NPA. And so
Yeah. Okay.
maybe, if it's okay with
Well,
you, Ed,
well,
again, I
let
don't
me
want to
take
cut into
five.
your time.
Hey,
So let's
Rick,
let's let's make this another session and do it in two.
let me
All
take
right?
5 more minutes. I'm gonna take
Sure.
5 more minutes and
Cool.
I'm done. Yeah.
Absolutely, no problem.
5 minutes and I'm done. And to summarize what I talked about for the first hour, to summarize that. This is what I talked about for the first hour and a half, right? And take 5 more minutes, and you have the light bending coming around the plasma rim of the sun, and there's no evidence of light bending up here, right? And that's been found. And not only myself, people who've done Shapiro effect and all these other effects, this has been uh, now profound, with no question whatsoever. And I talked about this, and to summarize all this thing back again, you have the plasma focal length of the sun is 550 astronomical units. If you can see light bending here, right? So that's all astronomers believe this, so that they have no problem with this. But however, coming back here again, if you look at the deep stars in space, you see no Einstein rings out there at all. So therefore, relativity should be with this. This is the experiment already been performed in astrophysics that defeats relativity. So relativity should be dead in the water with this. So there should be no problem whatsoever with this. So let's go forward. And the question is, where are the Einstein rings? Now, the reason why the Einstein rings are not seen is because these light rays are going past these stars, all these stars out in deep space, right? And if there were any bending whatsoever, the images out there would be blurred. But that's not the case. The Einstein rings are not there because of this image, right? For that's a fact. And the solar light bending, based on I have a referee paper published where I calculated this result. I have the plasma bending of the sun based on the minimum time effect, the minimum energy path of a light going up like the plasma of the sun. The plasma being gripped by the sun's gravitational potential gradient. And we talked about the potential gradient affecting the atomic clocks. The same thing that causes the tidal force on the Earth by the moon, that tidal force acts on the gravitational gradient field of the potential plasma of the sun, the atmosphere of the sun. And I come up with the solar light bending of the sun, given that same thing. I'm going to skip over this thing right here, and I'm gonna go to this. I'm gonna take 5 more minutes and just start to describe this. Here's a paper that I published calculating the gravitational light bending of the sun based on the minimum time and minimum energy effect, and I come up with the four times the gravitational gradient times the mass over RC squared based on this minimum time effect. And I get the same equations as general relativity, but nothing to do with relativity whatsoever. And that shows the fact is that. Now, it takes about 3 more minutes, and I'm going to summarize all this. And you go to my website, you can see this. This is published on my website. You can see this going to significant findings on the website. And Greg can give you the website right here. And matter of fact, I'm gonna post the website. And this calculates based on that the light function gravitational potential gradient of the sun and the redshift of that, putting these in the equation, and it comes out real nicely to the same equation as general relativity. But this is not relativity. This is based on the minimum energy time effect and the least time effect of the gravitational path of light in the plasma atmosphere of the sun. And that's what I published. Now, here's what I'm going to take 2 more minutes on this guy. This is what I think, puts relativity to rest. This image right here. This is at the center of our galaxy, and looking at an object that's 26,000 light years away from us right now. This is what we see right now going on. These stars are orbiting about this thing, and this is a fast playback. And if you observe this thing for the past, this has been observed for since 1992, I think it is, and until about, this is played back from 1992 to 2007, I think that is 2001, 2, 3, 4, 5, 6, 7, 2007. From 1992 to 2007, played back fast, right? This is a fast. These are snapshot images of these stars orbiting about something out here where this red X is. Where this red X is, most of the astrophysicists believe this thing sitting right here, a supermassive object, 4 million times the mass of the solar system, the sun, planets, and all that. 4 million solar masses are sitting right here at this object. And here are these stars orbiting about this thing. And this is a fast playback of the ultraviolet images. We can't see this with ordinary telescopes. We can't see this with optics. The human eye cannot see this. These are infrared ultraviolet images coming from this region, played back since 1992, real fast. And this thing, this star here called S2, orbiting about this, there's no evidence of any light bending there whatsoever. And that tells you what happened. Here's a star called S2, the most well-known orbit in astrophysics to this day, right? And here's another star called S3. This thing comes in so fast. It whirls around that object, which is called, they think it's a black hole. 4 million solar masses sitting right here. That star comes in so fast, and for that reason, I'm gonna click fast and I'll show you something else. Let's blow this thing up. Now watch this star, S3. It whirls around that thing, and it has a velocity of nearly 3% of the velocity of light. What does that tell you? That tells us one thing, that this image, all this area right here, whatever that is, that must be the best vacuum in the universe, one of the best vacuums, right? And since this is so good vacuum, if there were any light bending whatsoever out here, you should see it, right? But you don't see any evidence of light bending whatsoever in this area. So I put that on my website, and I can show you the images on my website. If you want to click here, I can show you that. And matter of fact, I will go down to that and take the last minute, and so we can go on. We can talk about MPA stuff, and which I think is important. So I'm going to show this this coming up on the website. Let me go to this thing. I'm going to show this. Click back here for a second. It's hard to see. Let me click back here for a second. I'm going to show this image down here, and I hope you can see this, because I don't know on this case. Greg, maybe you can tell me if you can see this. Now, if there were any light bending at all in this area, looking at that image, I'm going to try to hold the camera still so you can see that. If there were any light bending at all, this is what you should see if relativity were correct. As that star approaches that black hole, you should see an arc of amplification of light coming back. You see what I mean? So can you see that?
Yes, I can. I was muted and I was talking away, and I realized now nobody was hearing the word I said. I was just saying, if the upper right corner of the screen, again, click that icon and you can see this larger if you want to see it. So, okay.
Okay, let me see. Let me see if I can do that with one hand. I'm not left-handed here. Let me see if I can do that. Upper right-hand corner.
Well, you don't have to do that. I'm just saying you can see it already. Everybody else needs to see that. That's your screen large.
Okay. What? Could you click it for me, Greg?
Well, everybody else has to do it themselves for
Oh,
themselves.
they had to do it themselves. Okay. Oh,
Yeah,
you gotta do what
that's
Greg
all I'm
tells you to
saying.
do. You can see this big. But right now you can see this and the other one, right? The big
Yeah,
one is
we can see both.
what's being seen, right? The big one shows you what's being seen today. The little one shows you what relativity should say. If relativity were correct, you should see that, but you don't see it,
You
right?
mean those Einstein rings?
Yeah, you don't see the Einstein rings at all. See?
Uh-huh.
I
And we
mean,
should see that if relativity were
that's
correct.
right. If relativity were correct, you should see that.
Einstein relativity. Yep.
Okay. Okay. All right.
So
That's
that
what I'm saying in a nutshell.
now, just curious, Ed, to make that blue one with the blue background that you just showed us is different than the one here with the black
Yeah,
background. Did,
that's
did
right.
you
Yeah,
add that, or how did you get that? How'd you
the one that I
calculate
did
those?
with blue background, I used general relativity and what relativity should predict based on
Okay.
the Einstein rings in the textbook.
Uh-huh.
The textbook physics that's taught in the textbook. That's what you should see. You should
Hmm.
see some blurring somewhere in here. Here
I,
you don't see any evidence at all. Let me go
ha,
one more case and then I'm finished. Right?
no,
Here's what here's
but
what
before we go on, can I just ask, has anybody confirmed that that is what the textbooks say? I mean, have you how many people have you shown this to, and they say, "Yep,
yeah,
that is what the textbooks say"?
you see this thing I'm showing right here now?
Yeah,
This is in textbooks.
I know, but
This
I'm
is
just
what
saying,
they
have you
say
gotten
when it should be.
any mainstream physicists to say, "Yep, that's what the textbooks say"?
That's what the
Or
textbook says right here. This right here. This
yeah,
is what if you're bending around black
I
hole,
know
you should
that,
see that.
but have you gotten any mainstream physicists to agree to that is what it says? That's all I'm
I got
asking.
some people who are on my side. I need to pull some cords of people who can make major impacts. And one of my friends in Germany said, I need to keep on doing what I'm doing. And one of these days, I'm going to get somebody who can pull some cords and make some things happen.
All right.
You got the silent majority out there that want you to
Yep.
go and be quiet. You
Yeah.
see what I mean?
Gotcha.
And
Okay.
that's what we're doing. You
Go
know,
ahead with your
that's
second
but after
example.
you, if science is going to change, it's got to be somebody out of our group that's going to do it. Right?
Yep.
It
Gotcha.
got to be somebody out of our group.
Okay.
But we got to raise
You
hell to
got
do it.
another example here you want to talk about?
Yeah, this is what we're seeing, right? That's what we see. We see no bending at all right here, right? None whatsoever, right? Here's a black hole, and there's this thing moving around. Supermassive object, see no bending at all. But however, if relativity were right, we should see something like this. You see what I mean? So I'm bouncing the observational evidence off the reality of of the series, what's printed in the textbooks.
Hmm.
So you get the textbooks and you got the observational evidence. That's what I'm doing. I haven't mentioned anything about Dowdey theory at all.
Yep.
You see? Right? Now, what I'm going to do, my friends are telling me, keep on doing what you're doing. And this is what you're actually seeing right now. You see no bending at all in the center of the galaxy. No bending at all. Right? And these are the Einstein rings based on the observation in the textbook. This is the textbook. Okay? Right? You know? And I'm explaining that, right? So you can go through this stuff. All these things you can do yourself, right? And you guys have the wherewithal to do this. This is obvious right here. You see? Okay. So then let me go forward and finish up here. And here are some things that show you, like this Lindzen galaxy, for example, right? Right. Based on the modern telescopes that we have, the light amplifiers and all these emitters coming from the deep space, you see light emitters and scattering of light based on the in intermediate space. And if it weren't for the medium space, we wouldn't know about this Röntgen star, you know, what's called X-rays in the German Röntgen emission, you know, the NKA, you know that this group observed this thing. If it weren't for this intermediate galaxy space, the dark matter in this space, this thing would be invisible. There's matter right here that does not emit light, and it scatters this light, right? If it weren't for that, so that shows you light is being scattered and bent by stuff that's between the stars, right? right? And not by the star itself. You know, so therefore, this is what I have. And I'm just gonna skip past this step right here and go to this thing here. I'll skip past all that. So all this is on my website, and you go to certificate finders, click on certificate finders, and just about everything I said is right in here. So
Okay. Glenn had one more question. Glenn, go ahead. Or comment. And Franklin, who is after that?
Dr. Dowdey, so what, do I understand you correctly that you're saying that all the general relativity equations are correct and that only the gravity light bending of general relativity is incorrect? Is that what you're saying?
I'm saying that the light bending in general relativity is correct for the plasma rim of the sun. However, it does not apply beyond the sun. When you get past the sun back into deep space where there's no plasma at all, then there's a problem with the general relativity, right? And I think Einstein did his job well, and I don't consider myself a basher of Einstein. And Einstein said in his own words, if the velocity of light is not constant in all frames of reference, then all my theories are wrong. And guess what? I said the velocity of light is not constant in all frames of reference, and I use Galilean transmissions of velocities, and I'm in Euclidean space. And I'm all my calculations in my book. I think a lot of you guys have my book, right? And
I do.
you have access to my website. I use Galilean transformations in Euclidean space geometry, you know, to calculate to derive all my equations. And I explain all this stuff using Galilean transformations as an emission series. I don't use any relativity whatsoever in my book, right? And I make people understand that this book has nothing to do with relativity. It is an emission theory, and that's why I am an emission theory.
Well, you really didn't answer my question. I say that the speed of light and the relative speed of light are two different things, which Einstein said.
Wait a minute. The speed of light and the constancy of the speed of light and the speed of light constant are two different things. The constancy of the speed of light.
I'm glad to hear you say that.
I have to say what I have to say because I have to. I put my words. I don't use any wasted words at all. And I say this on my website over and over and over again, in my book over and over again. There's a velocity of light constant and there's a velocity of light constancy. Those are two different words. The velocity of light constancy says that if the source moves, then the velocity of light is additive to the source. Relativity says the velocity of light constancy, the velocity of light constant is all on all range and all fields of reference. The velocity of light is constant in all fields of reference. I don't say that. I'm different. I'm using the velocity of light constancy, saying that the velocity of light c prime does not equal to c, and the c prime is equal to c plus v. That's what I say.
Well, I talk about it as the speed of light and the relative speed of light, and they're not the same, and Einstein said they are the same. But that didn't answer my question. Are you saying that all of the general relativity equations are correct and only the light bending of gravity is incorrect? Is that what you're saying?
I say the time dilation is also not the correct explanation of nature. Also, I call it a time dilation, but I call it transverse relative time shift. I get the same equation as relativity, but for a different reason.
That's special relativity. Your site seems to suggest that all the general
I'm attacking both general relativity and special relativity, both of them.
Okay, so you're saying that all the general, just forget special relativity, all the general relativity equations are correct, you're saying, except for the light bending part of general relativity. Is that what you're saying?
Okay, I'm going to say this one more time. I'll make one more statement. General relativity, as far as Einstein did his job well, based on the Lorentz transformation and the warp space and all those things, the relativity, what Einstein did is correct based on that. If you have warp space and Lorentzian space in nature, then relativity will be correct. But however, if one of those things fail, then the whole theory must be wrong. Einstein said that in his own words. I'm taking Einstein for his own words. He said in his own words, if the velocity of light is not constant in all frames of reference, then all my theories gravitation and electromagnetism is false. Right? That's what it said. You know, and I quoted Einstein here in my paper. I quoted him saying that. You know, here's what Einstein said. I wrote in English down here. The velocity of light is not constant on a tiny bit dependent on the velocity of light source. Then my whole theory of relativity and gravitation ist falsch. Einstein said in German, wenn die Lichtgeschwindigkeit auch nur ein bisschen von der Geschwindigkeit der Lichtquelle abhängig ist, dann ist meine ganze Relativitätstheorie und Gravitationstheorie falsch. That's what he said.
Put that in your pipe and smoke it.
He said it in German. I'm taking him in his own words, right? And I'm not a basher of Einstein. Here, Einstein was at Lincoln University, Pennsylvania, and he was one of those fortunate guys who escaped Nazi persecution in Germany. He would have been probably gone to the gas chamber if he hadn't left when he did. Niels Bohr and a number of other scientists came over here with him at that time. And I know one of the professors who Einstein held the door open for this professor. He walked through. I didn't know he was at Lincoln University, but he was here, got an honorary degree from Lincoln University by Dr. Horace Bohm, having escaped in 1946. This is 1946, this picture. And I put this on my website. That's on my website. And I believe I'm not a basher of Einstein, and I believe the nature, all of nature is Euclidean. We don't need relativity, we don't need Watt space to explain what's going on out there in deep space. And I think it's all Euclidean space. And that's what I am.
Sounded like WAP space is Hispanic space.
I don't take no president. Greg, I told Greg I don't take no presidents, man. I don't play games either.
All right, Glenn, are you done?
Well, I just would let you know we disagree with a lot of issues. Okay, that's he answered my question.
Okay, fair enough. Okay. Franklin, you're up. If you got a camera, why don't you turn that on?
Okay, there I am.
There you are.
So I only have one question. You know, this has to do with your very first slide and your website where you show like this chart, and it shows that there's no deflection past just the plasma limb, which I think is great. But what I was looking for was the actual reference to the experiment that you're getting this data from. I expected to see, some star saying this was measured by such and so experiment. And so I want to know, what is your reference for that observational evidence? It's not readily apparent in your website.
You go to my website, all the references are there. And
I see the references.
And on all these pages, you go from the significant findings back to the significant findings pages that I gave you here. I'm going to show you.
Well, I see those references, but which one of those actually has those numbers in it? Because I see things about Chappell delay and things like that, and like the density of plasma. But what I'm really looking for is someone who is the place that you took that data from.
You look at all the papers that have been published on the gravitational light bending of the stars relative to the sun. Look at all of those pages which I referenced in here very carefully. Look at all these, and we'll go back to this.
Well, that's my question, because I don't necessarily want to look through 5 papers.
So you're going to have to do some reading. You're going to have to do some reading, because I have published papers in a number of referee journals, and I have a whole host of publications here which I put for your convenience.
I'm just asking you, what is the experiment, right?
Yes, I'm showing you this right now. Just a second.
Is that the Chappell delay? Is that where I'll find that?
I'm going to put my camera on it in just a minute.
Okay. That's a good question, Franklin.
Okay.
I mean, if we're dealing with experimental stuff, we need to see.
My camera shows all the publications that I have on page.
Yes, I see that.
You can go to this website, my website here, and I show you all of my publications here.
But yeah, these are your publications, and that's not what he's asking for. He's asking for
these are some experiments, but I don't see how, like, say, the electron density profile of the outer
Oh,
corona.
I'm the only one to calculate it. I'm the only one has published so far the results on the uniform energy path and the least time path through the plasma getting relativity. I don't think anybody has done that but me. I'm the only one that has that result.
What I'm looking for is a measurement showing that there's no deflection past the plasma. I mean, even the other reference that Nick gave,
Let me back up. Listen to me one more time. I calculated the minimum energy time path of electromagnetic radiation going through the plasma. If you go in the vacuum, there is no deflection whatsoever. And I said, in my principle, what I'm taking right here, in my principle, I said the light bending in plasma only, not in deep space. But guess what? There are others who will find that relativity is not present in deep space. And you can talk to some of the other guys right in this group that just mentioned a while ago.
That's the experiment I want to see. I'm not going to just take your word for it that there's no deflection beyond the plasma, because I mean, clearly, you have calculated that there will be a deflection around the plasma, and clearly we know that's going to be the case.
Yes,
but you also have to prove that there is no deflection.
I have proven
past the plasma.
The experiment is already done by astrophysics. All you have to do is look at the evidence. It's already there. Just go look in space and you'll see. All you have to do is open your eyes, look at the telescope, look at the published information they have already. And I show you a number of papers that have been published already. They show no deflections of those distant stars. And look at my reference papers when I publish this stuff. I published one and I have 2 or 3 papers published here. I'm going to show you one paper that I want you to take a look at. One of the papers I have, a referee paper, time-resolved images from the center of the galaxy appear to counter general relativity. That's in Astronomical Nachrichten. That's a published paper in volume 328, issue 2, published in 2007. It's published in Astronomical Nachrichten. There's another paper published by Physics Essay, Extensionship of Pure Classical Alternative to General Relativity. That's in Physics Essay. Then I have another paper coming out in German soon, Löschbeschichtungsprinzip and classical alternative to allgemeine Relativitätstheory. That's coming out soon.
That's all very impressive, paper, but all I'm looking for is a single reference. All I'm looking for is a single reference attempting to measure the deflection of starlight past the sun, showing that according to your chart, negligible deflection. That's
You look at all this data. Here's another paper, Lebach et al., measurement of solar gravitational deflection. There's a solar gravitational deflection of radio waves measured by these guys. There's 3 more references down there, very long base infant references. Look at those papers, right? I published those right here.
Franklin, I don't think you're understanding. He's saying in his papers, he has references to experiments that show him that he did not do. Okay.
Yeah, that's what I'm looking for. So,
okay,
like,
that's what he's
of these 6 references, which one do I find that in?
Of the 6 references.
6 references in your website.
He can do that offline. I think.
Look at any of those papers. Look at any of those papers, and you'll find out when they go out beyond the sun for 2 or 3 radius sunrise out, you have none of those deflections taking place. All you have to do is look at it.
Okay, I'll take a look at them.
Would it be fair to say, Ed, that they didn't do it? I mean, the experiment wasn't intended to find the absence of deflections, so they don't it was sort of a byproduct of the experiment that they were doing. They were measuring stuff, and they didn't really. It was an incidental thing that they didn't even happen to notice. It's in the data, but it's not like they were looking for that, so they didn't find it.
So you got a silent majority out there. They're not going to say anything because they're embarrassed about it, And I said it on my website. There's a number of people out there that are embarrassed. They don't want to talk about this stuff. That's the problem. They won't talk about it. But I would force them to talk about it. I gave this presentation one like this at NASA Goddard Space Flight Center when I was there. There's dumb people out there. They know rocket theory. They can put up satellites in orbit. They know how to. When you put an atomic clock in space, you know what they do? They make the atomic clock. What they do, they force the atomic clock to run slower while it's sitting on the Earth. And one that's sitting on the Earth, one is running faster. But when they put the thing in space, it's running at the right speed. They trick it up before they put it in orbit. These people know nothing about relativity in general space. They're rocket scientists, right? They don't know the stuff I'm talking about. I've become an expert on general relativity because of my theory. I'm defending my theory, and I'm become an expert on general relativity. I have no intention of doing relativity, but I've become an expert on relativity over the last few years because I'm showing other people they need to look at my theory. And what my goal is put relativity, shut it down, send those guys home at Princeton University, and I said, okay, I got this theory for you. Then I want to take my book and replace relativity with my book. That's what I want to do. Like I said, I
Well,
take no prisoners.
the fastest way to do that would be to show a direct experiment that's been done, which proves your chart.
No, I have done it
So
already.
I'm
I've
just saying
done it already.
it's not clear to me from your website that
All
that's
right,
there.
well, you need to go look at the papers that I published on my website and look at my publication.
Okay, I'll do that. I'll
That's
take a
right.
look,
All right.
Okay.
and I'll come back
Good.
with you
And good luck.
if I
All right.
haven't found
Guess what?
anything.
I sent guys to the library. They go away mad with me. Come back next week. And I send them back again. They come back mad with me. I send them away, and I don't hear from them anymore. So I
All
hope
right.
to hear from you several times. Okay. All right, Doc. Very
Sounds
good.
good. I think
All
somebody
right.
it really wants to get to the bottom of it. There is
All right. I want
definitely
to get to the
evidence
bottom of
there.
this thing too.
All right. Well, we are now coming up on 11 o'clock, which is our time here. Did you want to take a couple minutes just to summarize one last time? And no more questions, but we'll just
Yeah,
a quick
I'll
summary.
just summarize one more time. I invite anybody to take a look at this and do what I did. And if people will just sit down, but first of all, in order to take a look at what I'm doing, you got to put the other stuff aside for a moment and then take a look and go back and take a fresh look, right? And an unbiased look, and you'll see what I'm talking about. And it's not hard to do, especially as Sagittarius A at the where you have the star S2 and S3 orbiting about this supermassive object, 4 million solar light masses away, solar masses, 26,000 light years away from us. Take a look at that. If that doesn't convince you, I don't think not too much I can say that will convince you. You have to have an open mind and look at that. Take an open minded look at these things at the website, then you'll see what I'm talking about. Go to significant findings, and anybody who has an open mind with significant findings, and you should be take it. But use the fundamentals. Use the fundamentals, right? Using the fundamentals, you want to be able to do this. And the men and gentlemen that I just talked to, he should be the one to do this. You sound like you're knowledgeable of this stuff. If you take the fundamentals and look at what I'm saying, and then take the observational evidence, clear observational evidence, right? Then you see what I'm talking about. You should say, oh, shucks. Then they get back to me, right? Okay?
All right. Thank you, Ed.
Okay.
Let's see. Now I do want to spend a little bit of time today talking about uh, issues relating to the NPA. So I think we can safely transition to that now. And Ed, thank you again for
Okay.
all that you've done. Let's see. I might want to go ahead and add the documents. Hopefully every one of you have seen this, and we had our discussion last week. And so this is, I'm just going to go ahead and put these up here. Hopefully you can all see that now. This is the first of several documents that we talked about last week relating to the whole situation. And most of you here, I think, signed the petition, and thank you for that. Not a lot has been happening over the last few days. We've been trying to decide, what do we do now? I'm getting a feedback from somebody. So I want to address that. Let's see, I'm muting Joseph. Okay, I think that took care of it.
My turn, Doc?
No, you're good. Yeah, you can mute now, Ed. Thank you. I'll go
Oh,
ahead
yeah.
and do it for you. All right, cool. Great. And so so that is the question. What do we do now? The fact is that Barry Springer and Jim Newbern have not stepped down, and so they're digging in their heels apparently, and plan on continuing with the course that they have. And so, what do we do? It would had been my hope and actually expectation that they would simply just step down, realizing that the vast majority of membership is not happy about what they've done with the NPA, and but for whatever reason, they have chosen not to do that. So now we need to make a more, I guess, official statement about what the members actually want. So I've been kind of struggling with that, but I am going to put something together here. Is basically a list of expectations for a resolution of this whole matter. And then the question becomes, well, what do we do in the meantime? Well, we do what we're doing today, and that is we continue or restart, if you will, doing the Saturday morning conferences. I think that's a big part of what the NPA membership would like to see happen. And secondly, David came home from his vacation, I think on Wednesday, and we talked on Thursday. Well, no, we talked on Thursday, I guess it was. And so David's had a couple of days. He's actually been teaming with ideas for things that we can do to build this community. So one way or another, that is, of course, has always been and still is his mission. And he has some excellent ideas, and I'm excited about them. One of the things we wanted to do for some time and haven't, for whatever reason, the NPA website actually has a lot more functionality than we've been taking advantage of, and that may actually turn out to be a good thing since we haven't used it. We can put a lot of that functionality into something new that we can all use and start using, and I'd like to encourage people to use right away. David's working furiously on those things related to the number one thing would be able to give us a mechanism to post our various discussions. I mean, there's been a lot of emails flying back and forth, and the problem with the email thing is, number one, you don't have a permanent record of what you were talking about. Number two, you end up getting people on the in the chain that don't want to get the emails all the time. And so how do you take them out? Because somebody forgets and they respond to an old email and blah, blah, blah. You get into this whole spam thing. And number three, it's not public, and so I think we want to make most of these discussions public. I mean, it is basically for us as members to have these discussions and to go back and forth, but then, we want to be able to refer to them years from now and say, well, back in 2014, Glenn Baxter said this, and Bill Lucas said that, and we want to be able to search it. That's another important, valuable thing of having online resources, that we can search it. So there are Yahoo groups and things like that out there, but those are not integrated into a whole system, which gives you the background of a website. So when you click on somebody's name, you know who they are and where they're coming from and some of their references and so on. So this has all been developed, and actually there's a piece of existing software that David, maybe I just ask him to tell more about that, is planning to make available to us. I think it's something like $500 a year. So just to be clear, we're planning on implementing this, and it's not an MPA thing. It's just something for independent scientists. And I don't know if it's time to announce this, but David is working on a new website, and right now it's calling it the Natural Philosophy Exchange, which would be just what I'm talking about, a mechanism to do exchanges in this way. And so we really want to encourage people, once we get it set up, to start using it. And in addition to that, this would be then the place where we could have people's papers posted, and then people would comment on other people's papers and have discussions surrounding the works and the papers. We really want to encourage more of that. There's been a little of it, but not nearly as much as there should be and could be. So number one, that means people need to start reading other people's papers and then making their comments on them, and constructive comments, obviously, and questions of clarification and so on. So we want to encourage that, and so maybe what I guess I'm trying to say is I want this this whole nastiness that we have behind us to actually become a positive and use it to propel us into some action, which is positive for the NPA, or for, I should say, the independent science community. That's my goal. Let's just, the negative doesn't have to be a problem. We don't, as far as Barry Springer and Jim Newbern are concerned, we don't even need the NPA quote organization. We don't need that. We just need the people who are interested in doing science. That's you guys. And we don't really need their money. If they're going to keep it and spend it on lawyers, well, I'm not happy about it, but it's not the end of the world. It's just whatever they're going to do. But we're going to just do science, and that's that's the best thing we can do. Just do science and come up with some better tools than we've had before, and start using them and build the community of people doing science as we're doing it, more than it's ever been done before. That's my hope for what we're going to do for 2014, regardless of what the outcome of this mess is. One last thing is there probably will be a new petition coming out in the next few days, and it'll be an explicit statement based on the membership of what the members expect. And then number two is that there will be some new things coming out for the NPA members, that is you guys, the independent science community, to start using, and we encourage you when they do come out to be proactive and start using them. So with that, that's pretty much all I have to say, I think. If David, if you're here, do you want to say a few words? Is this a good time for you to get on?
Can you hear me?
Sure can, yeah.
Okay, well, I don't want to belabor it. It's been out there a lot, but I do want to thank everybody for their support. It really has been very hard for me emotionally. I really want to thank Greg, first of all, for the entire time supporting what was going on. It was just such a shock for us for such a long time, even for months, to believe what was happening, that it just took a lot for us to even believe what was happening. But through it all, Greg, I have no words to thank you for your support, and of course the support of everybody in the MPA. That's been very encouraging. And I guess the thing I would say is, Greg, is that we do have to have this petition coming out, in my opinion, because it's going to be a little weird for us to go off to Tesla Tech. What are we? Are we the MPA, or are not we the MPA? And that gets to be a little bit, how do you say, hard to understand. So I think a person I met in Brazil when I was there, actually one of the Brazilian, Luiz Sobon, who's been at a number of our conferences, came by, and he was very supportive of the whole situation. He came literally by the airport to give me a hug and talk and say, hey, it's all going to be great. But he also said, we do have to take a few more steps, and I think we do. Since people haven't stepped down, we have to make some distinction, because again, we can continue, and I have no problem, and I think the stuff that I'm developing right now is going to be fantastic. It's sort of like Facebook for the scientists, but we do need to get some clarification there, in my opinion, Greg, and that's why I think a lot of people, we need to take those next steps, because we can go forward and do these conferences, but is this the MPA? Is it not the MPA? What's been resolved? Members, there has to be some resolution, even if it's the members themselves who have to do that. And so it's greatly appreciated, everybody's support, and I think the next petition will try to clarify some of that. But I certainly feel we have things, as much as we want to keep going forward, which we will do with these video conferences. We need to know what happens if the case is all of us are going to end up in Albuquerque along with Tesla Tech. Who are those people? What are we called? Those things do need to be resolved. But thank you again, everybody's support, and we'll have more information about the new stuff we're developing. And just to let people know, it's completely divorced from GroupM and World Science Database. So for right now, so there will be no problems there, no interaction. And for those who wonder why some of these events are happening on the World MPA site, we no longer have control over that. I passed that over. but it happens that they grab events from the World Science Database, and the events for the MPA are in there. Only the MPA can get at them, but that's why you see that. But thank you very much again for everybody's support, and Greg, thank you so much. I really don't have words, but and as last thing I do want to say is about the film. I'm going on Monday to have the final cut. We're sending it to Cannes. It was rejected by Berlin, Film Festival, but that's not surprising. They rejected it way too fast to have looked at it. I think they saw the title and they love Einstein so much that was rejected. But I'm sending it to Cannes. We've sent it to Tribeca in New York with Robert De Niro. It's been a couple months, so good news is it's not been rejected. So expect Einstein Wrong to be in the festivals this year in 2014, and then in the end of 2014 to try to qualify for Oscar nomination. And thank you so much for everybody's support. No, it's not available online. No, it's not going to be in the theaters until we get to a festival where a distributor may be interested, and they will start to come up with a distribution idea. But it's been very well received. It's for the layman, and the number one thing is they love the story, and then they become very endeared to the scientists. And I will have to say that Pal Asija is hitting off the charts in the general audiences. So Pal,
They love
get
Pal,
ready.
huh?
Yeah, I don't know. They've got this thing for Pal, but thank you everybody.
It's the
For
pen.
their
I know it's the pen.
it's he says some very good things too. The people who are in the film, I want to thank everybody, and the credits are there, but they're
Well,
great
Dr.
things
Dowdey's in
said.
it too, quite a bit.
Yeah,
too.
Dr. Dowdey. In fact, Ed Dowdey, you're going to owe me the video of that one same video of the center of the galaxy with the Einstein rings. So I need that one. I may put that in the film, so I'll talk with you. But thank you so much, everybody.
Okay. All right, I'm ready to open things up. I did want to say one more thing that I didn't say earlier, and that is, in this petition, some of the things that we want to talk about saying, and again, I'm still kicking this around, and this is why I haven't really come out with anything lately. What's reasonable to demand. So what I want to do is prepare a statement that is that members of the NPA, that is dues paying members, people who've actually spent money, given to the NPA. What should they say? I mean, they have a reason to have a voice. And so we don't really want people who are not quick, technically actual members signing the petition. So which is why we haven't tried to get thousands of people to sign the first petition. They're not members. I mean, they may support our cause, but that's kind of why we haven't made a big deal out of that. So we got to, I think it was 148 signatures, and that's a pretty good representation of the number. I think the number of people that have actually paid dues. I don't know what that number is, but I want to say something on the order of 300 to 400.
No, it's paid dues is on the average between 200 and 300. It fluctuates.
Okay, so it's well over half then, or it's definitely half, and I know that there's another probably 30 to 50 people that for one reason or another they couldn't read the files, they couldn't get to the petition. I get emails like this, and I don't even know how to answer them. Somebody's making a lot of noise here. I would love to have someone who can take emails like that. I think that might have been you, Franklin. I'm going to mute you. Anyway, so hopefully we'll deal with most of that this time. We're going to have the documents available in 3 different formats, so PDFs as well as the online things. And I know there were some issues related to, what was it? JavaScript was interfering for some people with their ability to see those documents. So anyway, I know about all that, and we'll try to fix that as best we can with the next time around. I'll write a new thing, and hopefully everybody will get it. And so anyway, that was a long diversion. All I was saying is that after the 148, I bet there was 30 to 50 more who would have signed it if it weren't for difficulties with not being able to get to the document or the website or something. So. Okay, and so my question now is, what should we put in this petition? So one of the things we could say is, we demand. I don't even know if I want to use the word demand. I'd lie to. These are our expectations. Is kind of the phrasing I'm thinking. I don't want to sound harsh, but our expectations are, number one, that the lawsuit be immediately stopped. and that Jim and Barry be step down, resign from their positions, and that the website be returned, the control of the NPA website be returned to David DeHilster, and that money, the bank account be made available to the members. And again, do the members want me, Greg Volk, to act as custodian for that? I mean, who should the money be surrendered to? I don't know how to word that. And the second thing is, what are the consequences if these expectations are not met? So we need to make a list of those. So that might include that the individual members will request or demand. I don't like to use the word demand, but we'll say request their money back. Dues that they put in, they want that back if these expectations are not met. That would be one thing. We do not recognize or will not use the NPA website. Or we do not recognize formally recognize the organization. We will, as members, choose to become involved with a new organization. Do we put that in there? I don't know if that's something we should put in there. Again, this new website is called the Natural Philosophy Exchange. Would that become the new group, or would we, do we say as members we're going to join this group, or I don't know. I mean, we're not going to charge anything for it, other than it does cost money, $500 a year to get all these tools. But these are the questions that are going through my mind. How do I, what do we put? I don't want. Oh, the other thing, and this is David's point, is we need to say the longer this delays, the more this becomes a part of the history of this whole thing. And of course, that goes on their record. So the sooner they step down and the sooner they meet these expectations, the better it is for them, because then this doesn't become a permanent part of their thing. We can get past this much sooner. So again, the goal of whatever this statement turns out to be is to come up with something that says strongly, but at the same time, I'm not trying to make enemies here. I've said several times in my letter and in other places that I do respect Barry and Jim, but at the same time, we've come to this impasse, so we need to make our expectations clear. So anyway, I hope that kind of gives you an idea of the struggles that I've been having. What do I do now? And I am opening the floor to anybody that wants to make any comments about that or make some suggestions, what you think. I don't want to overstate what the members would want to be said on their behalf. So, Glenn, is your flag up from before, or do you want to talk about this?
Yeah.
Go ahead. Oh, yeah, it's from before. Okay, all right. So, no flags up. Bob DeHilster had a flag up. Oh, now it's up again. Okay. Bob, go ahead.
I gotta find the right button.
I hear you.
Wait a minute. There we go. Put my mouthpiece down.
Video there?
And I'm working on video if
okay.
It'll ever show up.
See you. We got you. We're good.
Well, mine is really an advertisement. Nothing to do with this latest issues you're bringing up.
Okay.
All right. Next week is a gravity meeting, and I wanted to make promote that and invite. You'll get invited, I presume, to the meeting. And it turns out that much of what was said today, I'm going to give a different opinion. Maybe not necessarily opposing, but have a different perspective on some of the issues that were talked about today. So I just want to make sure that everybody is aware of that. I was going to interject any number of times, but I realized I'm going to have 2 hours next week. I'll take those 2 hours next week, and we'll.
Great.
I'm getting myself positioned better, and
awesome.
and talk about other things plus some of the issues that were talked about today. So
Okay,
hopefully you'll all be there and we can discuss those things.
great.
In any case, I support Greg and Dave's efforts and hope it all works out for the best. Thanks, Greg.
Thank you, Bob. All right, and yeah, like I said, the number one thing is let's just get back into doing science. So, okay, so Glenn, did you want to talk or not? Your flag's popped on and off several times, so I'm not sure.
Yes, I want to talk. I have two
Go
questions.
ahead.
First of all, congratulations. This session today was one of the best ever.
Oh,
Uh,
cool.
Very good, very well attended.
Yep,
The attendance is as good as ever that I've
yep.
ever seen.
It's about we didn't
Okay,
lose anything.
no. Number two, okay, this is my question. Today's video teleconference is and was promoted on the NPA site. Have you got, is this, are they blinking?
Well,
Is there any significance to that?
no, there's no significance to it really. David did talk about that a minute ago. The point is that it's just the way the NPA site is set up. It just automatically when we put a new event onto the World Science Database, it's automatically picked up by the NPA site. And there's nothing we can do to change that because they have control of the site. David doesn't have control of it. So it's not a big deal. It's just nothing to worry about.
Okay, number two, has anybody actually talked on the telephone with Colonel Springer?
I have not spoken with him for for weeks.
Okay, wouldn't
But
it be a
there
good
are
idea?
I have been in contact with other people who have. So again, I guess maybe I need to bite the bullet and do that.
I think
Um,
you should. I mean, you do a great job, and you are the face, really, de facto of NPA.
okay.
And call him on the phone. And if he doesn't want to talk on the phone, that speaks volumes
Yeah.
to me. Okay, that's
Okay.
my
I'll do
questions.
that.
Two questions. Yeah,
That's not something I look forward to, but I'll do it.
certainly
Okay.
understand that.
All right. Anything else, Glenn?
No, that's my question.
Okay, Nick, you're next, I think. Then Paulina is after that.
First a question, minor question, but it's something confusing. When I click on members on the NPA site, it comes up and it says there are 792 members. Does that just mean there are 792 people in the WSD?
That's a good question. We've been struggling with this for a long time. As
I
far
can
as
answer the question. It's very simple. The way the whole internet works and the way any type of marketing works, and this is my decision because at the time I was in a vacuum since no one was really caring. But basically what it is you want to attract people to the MPA. So what you have them do is register for the site. The process of registration is not simple. You got to put in a lot of information. That information is then put into the database as a person who's interested. They're not a member until they pay, but that gets them in the door, gets them to see certain things. They can't do certain things. They can't make any posts. They can't be part of the MPA conference. So it's nothing more than any other site which says, hey, sign up for our email list, and you sort of get emails, and eventually you bite into it. That's the idea. It's a simple thing of, hey, let them get their foot in the door, let them wander around and get them in. So out of those 700, we have between 200 and 300 that are actually paid. And also the other decision I made, and these are very conscious and very well thought out, having worked with the MPA since '96 in one form or another, is that there's a period that I chose of 3 years, and the board did know about this before the current board. And that was, I said, okay, I'm not going to ding somebody because they paid their dues 2 years ago, and in their mind they think they're a member. So I made a period of 3 years. So if you've paid your dues within the last 3 years, you're considered to be a member. That's just because of a sort of a courtesy. Okay?
But technically, I mean, if you want to publish a paper, then you need to get current.
Yes,
So
yes, exactly.
that's
But
the idea.
I don't. The members there, are people who are interested in the MPA who filled out a very long form, which includes their email, their address, their phone number, and they have to fill that out. So it's not a course that they're just signing up for a newsletter and, oh my gosh, we're including them. Okay?
Well, then there's also the issue of there are some people who apparently have had trouble being able to pay their dues, and so they would, but they haven't actually paid it yet. And there's a lot of people that not sure if they're members or not. So, anyway, it's not a big deal. One thing we do want to say, and I guess it should be obvious, but I should say it, and that is we're encouraging people to not pay membership dues, at least until after this whole thing is resolved. Hopefully that's clear enough. So,
But
all
there have
right,
been
Nick, did
people
that
who
answer your
paid.
questions?
They have been people who paid, including my father. That money, and I want my father to know, is not to this group. That goes into the bank account that's controlled by James Newbern. So
Right.
anybody paying their dues in the last month, no offense, it's gone. So.
Yeah, it went to pay lawyers. Yeah. So, okay. Nick, did you have anything else, or?
Yeah, let me just comment also on what you just said, and that is, I've heard someone say that the membership has declined, but I think it's been a very positive thing that the website has brought nearly 800 people who are interested in the NPA and maybe browsing around, and out of that, I'm sure we will get some more members.
Yep.
Okay, to the main point I was going to make, the petition, the initial petition, I think was a tremendous success.
They seem to be saying that if you joined within the last 3 years, you still belong.
Yeah. Right. Anyways, I'm transitioning
Right.
on to the next point with saying the petition you made, we had nearly 150 signatures, plus you can honestly say, hey, there are about 30 more, and that really represents most of the most active people. And they're asking that Springer and Newbern resign. I think there is danger into going and asking for a second petition. The way I would approach it is simply to communicate to Springer and Company that, hey, here's the next steps that we will be following, but don't ask that the 150 re-sign up for all of these individual steps, because then you start fracturing and people get tired of
Yeah.
continuing.
Good point.
That's my only point.
That's a good idea. I think.
Yeah, that's kind of what was bothering me too, Nick. Is are we just saying the same thing over again? They've already said they're given their support, and so if they give their support to one, why wouldn't they give their support to the other? Yeah.
And they can decide on an individual basis on all these other things without going through signing up this petition for this and that.
Good.
And
Yeah. Yeah, that's kind of was my feeling too, and that's why I was kind of uncomfortable with this whole second petition. But nonetheless, I guess it's incumbent upon me to create some sort of a formal statement of expectations. You think that's fair?
Oh, absolutely. You can communicate
and
whatever you want.
I'm saying it on behalf of the members.
Steps. That's fine.
Okay.
But I think it's important.
We have the petition, but it says 100, maybe 180 really are asking you to resign. So resign. Right.
Yeah. Well, I think it's important that the group has to make some formal statement. I think, Greg, you put together in a letter, and put those things there, because if we ignore this, what do? We're having these meetings. It's not clear to anybody new where they're coming from, because when we put them in the World Science Database, they will pop up on that other site because we don't have control of it. When we go to the Tesla Tech, if we do that, which would be great, in July or whatever, what is that? What people are going to say? Well, are you from? Is who's? People are even confused now. So I think we need to have that statement. The statement is. And the other thing too, I think another point I've talked to you, Greg, is that when you have a revolt, if you have a government and you're in a country like in Egypt, you don't worry about today. I think a lot of people get dragged down into the bylaws of what they said. It doesn't matter anymore. Right. The revolts happen. Whatever was there is gone. It's been wiped out. Now
the example I like to give is when the Americans declared independence, they weren't looking for code in the British law, for them to allow for them to have a revolution. They just had a revolution, and because that was what the will of the people was. And so it's the same situation here. Once if we're dissolving the board, we're saying, the bylaws and everything in the current NPA structure just don't apply, because the people, the members, are saying that they're not happy with the whole situation, and that's really the position we're in. So yeah, we don't need to worry about the bylaws or whatever, the current NPA structure has to say. All right.
I'll
Greg,
summarize.
I
I
have a
say
question.
we have
Wait. Let me get control here. David, are you done? David's done.
This is
Okay.
Nick.
I'm
I want
done.
to just summarize what
Nick,
I'm saying.
go ahead, Nick, and then
we,
Harry,
we
you'll be next.
have a really potent petition. It's so potent. I have no idea why they haven't resigned. But anyways, and that is our flag in the ground. Now the next steps are you communicate to to Springer and New Bern via letter, and you communicate to that mailing list of all of the people who've signed, and you say, all right, this is what's going to happen in the future.
Sure.
But no more petitions.
Okay.
No more formal petitions.
That's fair enough.
We have an overwhelming
That makes sense.
vote on that.
And the other thing is, I don't think that we need to seek more signatures from non-members. I don't think that really, accomplishes anything. The majority of the people that did are, in fact, the members. So, which makes sense. So, and I don't know, is there value, what I'm asking, in just trying to get more people to sign this thing and make this even more public, or have we got enough? That's the question.
We have enough. The revolution has happened, so.
Yeah, okay. That's kind of my feeling too.
And people can go in and sign. There's no problem.
Yeah, and by the way, I would like to, you brought this up earlier, Nick, I'd like to address the whole membership attendance issue that Barry brought up. And again, well, first of all, I think Barry is laboring under a misconception. We had a great success in 2011 in College Park, and a lot of that was due to the fact that we invited the Electric Universe community to come to our conference, and that was through our relationship with Dave Talbot, which I still have a good relationship with Dave Talbot. So our conference attendance was close to 200. But you have to understand that more than half of those people that were there were Electric Universe people. Way more than half. If it had just been the NPA core, as you will, it would have been under 100 easily, and it would have been, that's what we had, in the last couple of conferences. And now it may have been a little more than what we had this last year, I don't know, but we had about 60, 70 people at this last conference, so that would have been what we had before. So attendance is not that far down. It's been slow and steady. It hasn't been growing, but it hasn't been declining either. It's and we do have close to 300 paid members. So and that's as many as we've ever had. I don't think even in 2011 we had more than that. So did somebody want to say something on that? Okay.
Greg, I had a question. Did they accept your resignation?
It's a good question. Not formally. So
well,
what does that mean?
Are you on the board or not on the board, or what?
Well, as far as I'm concerned, I'm not. I did get an email from Jim Newbern saying, despite your resignation, something about the Sanyak Award, so that sort of seemed like an acknowledgement of the resignation. I don't think there was. I don't think anybody ever thought of actually having to accept it, but I suppose Barry probably would think of that. He's very good in that way, as far as.
All right, I have a question, follow-up question. Regarding the money dispute, is there anything happening on that, or is that just status?
I don't know. Like I said, I am not in communication with either Barry Springer, or Jim Newbern, so I don't know what they're doing. I don't know if further money has been spent.
Yes, sir.
Is there any kind of negotiating going on, or is it
no,
just...
not at all. I think I think they were hit blindsided by the MPA dissolving them. And also, just on the resignation, Greg, they posted on the World MPA website. There was a statement saying now that David and Greg, who are both resigned, have
Okay.
brought this to the
There you
public.
go.
So there's an acknowledgement there. As to what's happening with the money, I think they're just so blindsided by this. Greg and I have been baffled. To give an example, Sam, who is the guy who is supposedly a programmer who is taking this over, actually signed the petition to put on their counter arguments why this is a dumb idea. Of course, he signed the petition to dissolve the thing he was defending. So it's been so far away from logic. It's almost dealing with the mainstream at times, having dealt with this. We couldn't even come up with putting our feet in their own shoes, trying to figure out what the heck these guys are thinking. So right
I will
now,
say, go ahead.
I did have a letter that was sent, I guess, to my older address, which I can't believe that they sent, believe it or not, to an address that I lived 4 years ago before I bought my house. But I got it from the lawyer. But from what I read in the lawyer letter, basically all they did was tell them their story and have a letter drafted. The lawyers probably didn't investigate anything. If I think they went back to the lawyers and they said, what's happening? Well, the membership dissolved us. I don't think the lawyers are going to go any further with it. So I think it's really in the hands of James and Barry, whether or not they're going to try to give up the money or not give up the money. I think it's really now, I don't think any lawyer is going to touch this with a 50-foot light year pole. So.
Yeah, one thing we probably should do is notify the attorney that we took this
Dave,
decision.
let me just ask this. You know, if I was in your shoes at this point, I'd just propose a settlement to them and see how they respond.
Meaning what?
Yeah, I don't know what settlement is.
What would that mean? Like you get
They
this
would
and I
pay
get
you
that.
the money and you'd agree, come to some kind of agreement about who owns what and move on.
Okay. The only reason I wouldn't do that is because the MPA doesn't recognize them, so we would be negotiating with somebody who is not recognized by anybody other than just individuals. And at that point, I'm much more worried about, in my opinion, because I know Greg it isn't. But
Well, then I'd write a letter to what's her name? Can't remember her name. The president.
Cynthia.
Yes.
Yeah, I mean, that's not a bad idea, but I think what needs to be done is to send a letter of what the NPA, the former NPA members are, because that's really what we are, unless we consider them having the NPA that needs to give it back. I like the idea that Nick, that is just send a letter, send it to everybody who signed it, to all the members, this is what's being signed, and ask them what we want back. And see what happens. I mean, at this point, we're really not dealing with, anything to negotiate. There's $16,000 that was in the bank at least, and we didn't even know that until 6 months after the conference. They would not. James Newborn refused to give us a balance. I kept asking Greg, we don't even have a balance. We have no idea how much is in the bank. I was a board member. Greg was a board member. For 6 months, we couldn't get the treasurer to give us a balance. So. The whole thing is, to me, I don't look at that money, whether it's paid to me or anybody. I look at it as all of my hard work, all of Greg's hard work, all of you guys' hard work, all of your money that's been put together, and it's not theirs, and it's been dissolved. The right thing to do is give it back, and we need to ask them that. And so it's not really a negotiation. It doesn't pertain to them anymore. And if they want to keep it, then it's in their bad conscience. They have to live with themselves. But that's the way I look at it.
Okay, now from my point of view, looking at this from outside, I see this as two issues. I see this as something policy dispute. Okay, that's something else. I don't know whether that's true or false. But if this is just a money dispute and a dispute about rights of the website, then I see that should just straightforward move to settle the issue.
Yeah, well, the money is almost secondary. It's I think it's control of the website is the main thing, so that we can any kind of a negotiation. The problem is, all right, let you get something and we get something. Then we're acknowledging that they exist as a separate entity. They are the NPA and we're something else. I don't know what that would mean.
I think that's already the case since you've resigned from the board. So.
Harry, it doesn't exist anymore, because that would be like saying that the members have said these people are no longer recognized. That is, everything is null and void. That it's a revolution in that sense. So you can't, the idea that, that there is anything, there isn't anything. The only
Well, then
reason
they can't vote to give you the money and
well, they
resolve the
can't.
thing.
No, that's
At
right.
some
Because what they
point,
need to do is we have to
you
ask
have to
them to
come to
give
an
back the
agreement.
toys that they have. That's basically, if you want to look at it in a simple way. Like children, you say, okay, folks, mommy and daddy, this magic kingdom you live in doesn't exist anymore. It's gone away. Please give back these things because they're not yours. I mean, that's all it comes down to. They're going to be their conscience of whether James Newbern and Barry Springer can live with themselves knowing that they no longer command anyone, and what they have was of that group, and giving it back would be the right thing. That's really all we have left.
Well, I think you need to write a letter and propose a settlement.
Well,
Okay,
I don't think
but the question I was trying to get at here is, what would that settlement look like? I mean, you guys get the website, but we're gonna put on the conferences. We're gonna do the Senyak Award.
It doesn't make sense.
We're gonna do the Saturday morning. What are you gonna do?
Greg, there's a thing that you said that makes no sense. You can't ask them to say they get the website. That makes no sense. It doesn't exist. Who owns the website of the MPA members?
Right.
I know. Directors aren't
that's
there.
what I'm just trying to show is the absurdity.
You can't make a bargain because there is no, in the logical world, there's no way they can end up with something because they no longer are the head. They are just two people now. They're no longer the head of anything. If you go to court.
I think that you need to write a letter, point that out to them and say, we want to achieve a settlement that is in the interest of everybody, and here's our proposal.
Well, I mean, essentially that's what the that's what the petition did. But okay, I guess we need to articulate even more clearly what that means. I mean, I just can't. I've talked to a couple people this week who are trying to come up with some sort of a settlement or compromise. In other words, that after all this was done, there would exist two organizations, the NPA and whatever David and I happen to concoct.
Well,
and if that were
do
true,
you want to do that or not?
No, absolutely not. I don't want to do that.
Okay, then I think you need to come to some kind of meeting of the minds. That's just my view of it.
Well, no, I think we've reached the point where that's the whole reason we came to the point of the petition was that it's no longer possible for us to work as we have, and the only solution is for Barry and Jim to step down, and then then the NPA members decide what they want.
A compromise where they can sort of, because having them step down is, I see that as them losing face, and I can see why they would want to dig in their heels on that. So is there a compromise that you can work out where they don't really lose face and you don't really lose face? And everybody...
I would say it this way. I'd say the sooner they do it, the less face they lose. That's my point.
Here's the thing, Harry.
They lose more face by waiting, by delaying the action.
If you take a person off the street, you read what is on that petition, you then see the number and say that over half the membership voted for that petition. The average person on the street said they've lost face. Now and I agree, Greg said it the right way. It's how much face they want to lose. And it's
I think your action at this point, I think you need to go to Cynthia and
I mean, that's a good idea.
Some kind of decision.
I mean,
She needs to make a decision and because I really don't see how you can resolve this unless you go to the president of the organization and ask that officer to do something.
Okay, fair enough.
Well, it could be addressed to her too. So
absolutely. Okay, Paulina, I believe you're next. Do you want to put in your thoughts? Are you there? I can unmute you. You have a flag up.
Maybe she's gone.
It's possible. It was sometimes it's a long wait when you're wanting to say something.
We're at 2 hours 45 minutes.
Yeah, we're way over time. So, Paulina, if you're not there, I guess we'll.
I think she's there because she just turned her microphone on.
I know, I did that.
Oh, you did that. I'm sorry.
Yeah, I thought maybe she didn't know. Okay, all right. Well, I'm guessing she's not there. We do need to close it up here. I thank everybody this has been a particularly long meeting, and I hope it was, I know we needed to talk about some of these issues. It's in my opinion, and the reason why we kind of did this as a surprise was we were hoping that that would, cause this whole thing to get resolved quickly, and that's still my desire. I want this to get done quick, and then we can get back to doing science and doing our Saturday mornings and doing conferences and doing awards and all those things we do. So I'm more than happy to get emails from people relating to what we should do. I would hope if you have emails with technical problems that you send them to David or somebody else. Those are not, I can't deal with those. That's just not my strength. I just said this before, but just let everybody know. All right.
Paulina is typing in. You may want to look at the chat.
Paulina's typing. Okay, the
is
settlement is in
giving
the interest of everyone. It's to stop payment for the lawyer's fees. Absolutely. Thank you, Paulina. No problem not having a mic. Yeah, I mean, maybe one thing we should probably do right away is to send the petition and the signatures to the attorneys so that they know. I don't know if they know that yet or not. So we'll do that right away. And I will contact Cynthia and write a letter. I think your advice is good, Nick, to not a new petition, but a letter, which is following the petition addressed to the current board, expressing our expectations. And I guess that's the next step. I think that the compromise is tough. I really have a hard time imagining how compromise is going to accomplish anything. I mean, I just can't imagine, how that could work and how that could be in the best interest of the membership. I'm willing to listen. I know some people feel that we somehow need to make a compromise. That would mean two separate organizations, and I just don't think that benefits anyone. The organization's not that big anyway. So anyway, that's my 2 cents worth. That's kind of where I'm at with this whole thing. Thanks everyone for their support. Thanks for being here. Let everybody know, if they don't know already, but that we got Saturday mornings happening again, and maybe we can get some new faces here as well. We got next week is Bob DeHilster's going to be heading up the Gravity Group meeting. The week after that is Jeff Cook is going to be, Jeff, you got to get me your abstract so I know what you're going to be talking about, but his stuff is always amazing. He always has great new original experimental stuff. And then following that, Dr. Lucas is going to be talking about he mentioned this quickly, the problems with the Pioneer anomalies and as it relates to his theoretical work. So I know that's going to be amazing too. So February, beyond February 1st, we still have openings. If anybody is interested in taking one of those spots, please let me know. Send me an abstract and a title. I'll put it in the schedule. Yes, it will appear on the NPA site, but don't worry about that. And we move forward. So is there anything else that needs to be said before we call it a meeting? No? All right, I'm going to stop the recording now, and thanks everybody for coming. We'll see you all next week.